Okay.
All right. Okay, Yang Berusaha IR Haji Muhammad Hatta bin Zakaria, Deputy Director General for Occupational Health, Department of Occupational Safety and Health, DOSH. Yang Berusaha Encik Ahmad Nazri, Director of Industrial Safety Division, DOSH. Mr. Eugene Lim, Chairman of the FMM Malaysian Industrial Gases Manufacturers Group, FMM MIGMA. Mr. Milan Saka, the Secretary General of the Asia Industrial Gases Association, AIGA, Mr. Chan Chun Bim, the Chairman of the FMM MIGMA Technical Committee, our distinguished speakers from FMM MIGMA, AIGA, and DOSH, and also ladies and gentlemen. A very good morning to all of you and welcome to the Industrial Gases Awareness Workshop organized by FMM MIGMA. Without further ado, I would like to invite Mr. Eugene Lim, Chairman of FMM MIGMA, to give his welcome remarks.
Okay, thank you, Pek Wan. Okay, Yang Berusaha IR Haji Muhammad Hatta bin Zakaria, Deputy Director General of Occupational Safety for DOSH. Encik Ahmad Nazri bin Abdul Kadir, Director Industrial Safety Division DOSH. Mr. Milan Saka, Secretary General Asia Industrial Gases Association, AIGA. Mr. Chan Chun Bim, Chairman of FMM MIGMA Technical Committee. Distinguished speakers from FMM MIGMA, AIGA, and DOSH. Ladies and gentlemen, selamat pagi, good morning, and welcome to the Industrial Gases Awareness Workshop organized by the FMM Malaysian Industrial Gases Manufacturers Group, FMM MIGMA. So FMM MIGMA is one of the industry groups representing the interests of the industrial gases manufacturers in Malaysia. And our objective includes setting up standards of operation and production, which we aim to lead to improved health, safety, and environment controls associated with the industry, its customer, as well as the general public. At this moment, we have altogether 10 members with the operations located all over Malaysia, supplying industrial gases, example, acetylene, oxygen, medical gases, specialty gases, etc., as essential products and services to various sectors of the economy, okay, ranging from healthcare and medical, food and beverage manufacturing, oil and gas, and as well as the energy sector. So in line with FMM MIGMA's objective, we have in the past organized such events, seminars like this every 2 years. So with the aim to educate as well as to share the experiences and lesson learned with our users, distributors, and manufacturers on the safe use and handling of industrial gases cylinders. And for today, when we actually were discussing what sort of a seminar or webinar do we want to actually have for this year. So we were thinking, let's work together with DOSH with the aim to provide awareness and share industry's best practices in the management of gas cylinders, ASU processes, and cold box. And in fact, FMM MIGMA, we are very pleased and thrilled, that when we actually approached DOSH, and DOSH was actually very receptive and supportive to this workshop proposal. And I recall when we first met and presented to Yang Berusaha IR Zaili bin Dola, the Director General of DOSH, on the March of 18, 2021. We actually got a very good response, and so therefore here we are today. So we are very grateful to Encik Ahmad Nazri bin Abdul Kadir, Director of Industrial Safety Division DOSH, for availing time for subsequent discussions with our technical committee to plan and finalize details of this workshop. So it is my hope that this workshop is the first of many interactions and activities that FMM MIGMA will have with DOSH to promote and elevate safety standards within our industry and our stakeholders. Ladies and gentlemen, while we had hoped that this workshop could be organized physically, as like our previous seminars, but due to the pandemic, And we believe that we can still actually continue with this workshop or seminar via virtual. And we hope that we can actually and that's where we are today, where we are still proceeding with this webinar virtually. We have a great lineup of presenters, not only from FMM MIGMA, but also from the Asia Industrial Gas Association, AIGA, which FMM MIGMA is a member of. Okay, and AIGA has been very supportive of our activities, and similarly to FMM MIGMA, they are a technical safety-oriented organization with the purpose of promoting safety, health, environmental awareness, and security in the production, distribution, and the use of industrial gases. They also publish and actively participate in the harmonization of standards across the gas industry on a global level with other gases associations in Europe, Japan, as well as United States. So we are also very honored to have Encik Ikhwani bin Ismail from the Industrial Safety Division, DOSH, will be sharing the recently published DOSH guidelines for industrial gases cylinder in bracket design, construction, handling, inspection, and testing year 2021, which I'm sure will benefit our members who are also in attendance today. Ladies and gentlemen, before I end my welcome remark, I take this opportunity to thank Yang Berusaha IR Haji Muhammad Hatta bin Zakaria, Deputy Director General Occupational Safety for DOSH, for availing time to open this virtual workshop. My thanks also goes to DOSH and AIGA for their support, and also the presenters for sparing their time to share their knowledge and experiences at this workshop. I'm very delighted to see many of you here today. When I was actually scrolling through the attendees, very encouraged to see close to 200 people on this workshop. And I'm sure those that log in, I'm sure maybe a few of you are also logging at the same time. So I'm actually very happy to see great response to this workshop. And I hope that all the attendees will find this workshop useful and fruitful. I would like to congratulate and thank the FMM MIGMA Technical Committee led by Mr. Chan Chun Bim for a job well done and all the hard work in putting this workshop together. Okay, I would like to end my speech with a word of thanks to everyone. Thank you very much.
Thank you, Mr. Lim, for your welcome remarks. Now, I would like to invite Yang Berusaha IR Haji Muhammad Hatta, the Deputy Director General for Occupational Health, DOSH, to give his opening remarks for this virtual workshop. Over to you, IR Hatta.
Okay, Bismillahirrahmanirrahim. Thank you, MC. Mr. Eugene Lim, Chairman of FMM, Malaysia Industrial Gases Manufacturer Group, FMM MIGMA, Cik Ahmad Nazri Abdul Kadir, Director of Industrial Safety, DOSH Malaysia, Mr. Chan Chun Bim, Chairman of Technical Committee, FMM MIGMA, Mr. Milan Sakar, Secretary General Asia Industrial Gases Association, AIGA, presenter from FMM Malaysia, Industrial Gas Manufacturer Group, and Asia Industrial Gas Association, AIGA, and distinguished speakers and participants. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi. It is my great pleasure to welcome you all to the Industrial Gases Awareness Workshop organized by FMM Malaysia Industrial Gases Manufacturer and DOSH. I'm happy to note that this workshop was initiated by FMM MIGMA, an industry group representing the industrial gases manufacturers in Malaysia. It was first mounted at engagement session between FMM, MIGMA, and our KP, Engineer Zali Dollah, on the March 18, 2021, and which was very much welcomed by our department. As the COVID-19 pandemic sweeping the world has rendered a large proportion of our industry unable to organize a full face-to-face workshop. As to mitigate the spread of virus, with this we organized a hybrid workshop where a workshop can be done virtually with a limitation of face-to-face session. This visual workshop is specifically focused on providing awareness and sharing of industry safety best practice with our DOS officer in the management of gas cylinders, air separation unit, ASU processors, and cold box. I trust that the industry knowledge and experience shared in this morning workshop will benefit our officer, especially those involved directly in inspection at the industry site. So on the May 24th, follow-up discussion on the proposed workshop with DOS is conducted, and few key areas has been highlighted, beneficial for both parties. This initiative by FMM-MICMA is very much in line with government aspiration to increase cooperation with the industry to promote and strengthen occupational safety and health standards in the country. I believe most of us prefer face-to-face workshop where we can sit, engage, and discuss in a discussion and networking into a better our industry. However, I hope this opportunity of hybrid workshop will open a lot of new possibilities for years to come. This hybrid workshop will have limitations. However, I hope that this limitation will not hinder us from exchanging knowledge and share the best practice in the industry. Let's make the limitation into our advantages. I hope also this workshop will kick-start a future dialogue and cooperation between industry and the government, such as FMM, MICMA, and DOS, where we can put count upon your expertise and experience in setting practical safety standards and regulation related to the industrial gases industry as an input to us. I would like to take this opportunity to record DOS appreciation to FMM, MICMA, as well as their regional counterpart IGA for sharing your expert knowledge for this workshop. We also thank the presenter from FMM, MICMA, and IGA for sharing your knowledge and experiences on the topics of interest by DOS at this workshop. I wish all the participants from DOS as well as from FMM, MICMA members company will end up with a fruitful workshop. Lastly, thank you for your attention, and I hope this pandemic will over soon, and perhaps we can meet physically in the future workshop. Thank you again.
Thank you, Yang Berusaha IR Haji Muhammad Hatta, for your opening remarks. May I now call upon all our guests from DOS, Engineer Hatta, Encik Ahmad Nazri, Mr. Eugene Lim, Mr. Milan, Mr. Chan, as well as our speakers and organizing committee member to turn on your camera. We'll have a quick photo session.
I'm very sorry, my problem with my camera.
Okay.
Sorry for that.
So
cannot appear.
All right. Encik Ivani Leonard. Okay, 1, 2, 3, smile. Okay, one more time. Okay, thank you very much. We will now move on to the next item of the agenda. Where we will have Mr. Chan Chun Bim, Chairman of the FMM MICMA Technical Committee, providing us or sharing with us a safety moment before we proceed with the rest of the agenda of the virtual workshop.
Okay, good morning, everyone. Thank you, Pek Wan. First of all, thank you to Engineer Haji Muhammad Hatta and also EJ Ahmad Nazri, Mr. Miran, and all the speakers. Thank you so much for supporting today's workshops. So before we start today's workshop, I just want to share with you the safety moment related to the motorcyclist safety. Pick one next. Okay, so we can see here, this is the distribution of deaths by route user type by the WHO region back to 2018. Okay, so if you can see the circle here in the red, this represents the Southeast Asia, whereby they have the highest fatality. You can see the orange bar chart there. 43% of the motorized 2 to 3 wheeler in the world resulted to the fatalities. Okay. So when you look at that statistic, we always think that, okay, this is just a statistic, right? But one incident happened back into 2018. There is a motorcycle accident, okay, whereby it's very close to my heart. Why? Because that is the time whereby my brother-in-law met in the motorcyclist so-called accident and resulted to fatality. And I still remember when I went to hospital to see him, when I talked to him, he can't open his eye, right? But I can see that the tears drop from his eye. So, but unfortunately, after a few days, he passed away. So always these cyclists' safety is always very close to my heart. So back to 2019, your next slide, pick one. We were together with IGA, would like to have this two-wheeler fatality prevention program. Okay, so if you can see the statistic here, from 2017 until 2020, in fact, in India, this is our so-called IGA members statistic. Yeah? So in India, we have 6 so-called fatality related to motorcyclists or two-wheeler fatalities. Malaysia have 5 cases and Thailand got 4 cases. So we know that this is very, very close, a very, very high risk in Malaysia as well. So MECMA was tasked to roll out this fatality prevention program. And when we do the analysis, we found majority of them are involved our youngster. Okay, so we are thinking that then why not we have a so-called let the local university student talk to the young people. That's why we have this motorcyclist safety video competition, right? So we, in order for those students understand our requirement and the safety information, so with help from IGA and so MECMA, we share the seminar, we conduct a seminar to all the participants to tell them what is the safety information you need to input into their videos. Okay, so we have a good participation from all the local universities. And over here, I just want to remind you all that there's 3 important points. Yeah? First is if you are the motorcyclist, make sure that your motorcycle condition is always in the tip-top condition. You have to inspect your tire, your mirror accordingly. And of course, you need to wear the proper PPE or the protection gear to ensure that people can see you, especially during night time, right? And last but not least is to have the safe riding motorcyclist. You have to drive defensively. For example, that you maybe have to have enough space or distance in front. Okay, so all of these informations the students have already put into the video clips. So you all can refer to the link later on. I will provide to you all. But I really hope that all the participants and all the guest speakers here can share this information, can become an ambassador for this motorcyclist safety. We really hope that whatever information you learn from this video clip, you can pass on to our kids, to our loved one, or even to our friends. Okay, we hope that together we can prevent all these incidents. With that, I hand back to Big One. Thank you.
Thank you, Mr. Chan, for the safety moment sharing. Ladies and gentlemen, we will move on to the first topic of the workshop today. which will be on the Malaysian Standards 2542/2013 gas cylinder package excluding LPG and firefighting code of practice. This will be presented by Mr. Anthony Wee, our member of FMM MIGMA Technical Committee. Okay, before we start off with the presentation, I'll just give a brief introduction of Anthony. He is attached with Linde Malaysia, and he is currently in charge of the company's supply chain and engineering for gas cylinders. He has over 20 years of operational and engineering experience in the gas cylinder industry, and he is also a chartered engineer with the Institute of Engineers UK. With that, I pass the floor to Anthony. Anthony, over to you.
Okay. Ya. Selamat pagi, Encik Haji, Tuan Haji, tuan-tuan dan puan-puan sekalian. I'll first start off with the introduction of MS2542. Next. Okay, we'll start off with the background and purpose of why we came up with this standard to begin with. Next, big one. Thank you. It was jointly developed and started in 2008 actually, due to the rising concerns. So in 2011, the group was formed to actually come out to formalize method of how we actually want to identify and also identify safe practices and also standards that we can use in the industry. We were lucky to be able to garner roughly about 90% of the manufacturers and users at that time that were involved together with the development of this standard. Next big one. Okay, so in brief, the cylinder standard provides the refiller a way to identify the cylinder package on its own. Afterwards, I will go through in details the breakdown in terms of the package itself, what standards are applied to MS2542. 2542 is actually a overall encompass of all the substandards, subparts of the standards that covers the entire package of cylinder itself, gas cylinder itself. It will cover new cylinders that we purchase into Malaysia directly and then fill and then supply. Also imported cylinders, imported in the sense that filled with gas already. Not the gas itself, that one is governed by another regulation, but the standard of the cylinder itself, and also exports of standards from Malaysia to other countries as well. It is to complement whatever practices that the industry is doing to any national regulation that might be adopted. Okay. Okay, so a brief standard of the standard of MS2542. I think it's big one. So it covers, as I said, new and used cylinders. There's two annex that covers this. One, Annex A, which is the design codes of the standards that we adopt. Annex B, which covers the testing, manufacturing, and also the design of the specific cylinder itself. It also looks at the compatibility of the material with both the gas cylinder and also the valve, looking at the specific gas type to the compatibility of the material that the gas stream would touch. Okay. Of course, the gas cylinder must satisfy GHS requirement and transportation of hazardous goods. So this is identified inside that standard as well together. Cylinders, as we know, we have what we call H cylinders before the development of the ISO and also the standards that majority came in the 1990s and the year 2000. So with that, we have additional annexes that what we call additional annexes that covers additional testing requirements to facilitate and identify cylinders that is safe for use. Okay, so cylinder testing must therefore follow MS ISO 6406. These are the subcategory standards that are under the umbrella of MS 2542 for testing for steel cylinders, aluminium, which is 10461, 10460, which is for acetylene as well. Okay, testing must be done for every cylinder. Stamping requirements, we have referenced it to a catalog, which is in AIGA 3605. This is a what you call an open source document that can be obtained. Okay. Brief awareness that we have to always be aware that gas cylinders, even though they are stamp markings, the records of the test reports are important and must be kept following to the duration. MS 2542 identifies the duration whereby these records need to be kept to a certain period of time. Next big one. Okay, so introduction of gas cylinder package. So there's three components for a gas cylinder. Three main components. We have the cylinder valve. We have what we call the valve protection guard that protects the valve and basically the cylinder itself. I will be talking in breakdown of these three main components. Okay, starting with the cylinders, the valve, and then the valve protection. Bundles and manifold, I have put it in here. However, it needs to be, because of the timing constraint, I think we will concentrate on the gas cylinder package itself. Okay, next big one. Okay, say gas cylinder package, how do we term it as safe? There's 4 key criteria that we have to ensure. The first is for us to ensure that it is resistant to mechanical loading. Loading in the sense that we actually fill and pressurize the cylinder, therefore stressing the vessel up. Okay, so in that sense, it needs to take into account of the cycles that it's taking. It needs to withstand that. It needs to be able to retain the pressure as well. It must not leak, and it must be compatible with the material and also resist corrosion, because externally it is still exposed to the environment. There's some pictures down there which you can see at the bottom of the slide that you can see on the issues whereby we have a corrosion and also failure in terms of mechanical loading. Yeah, big one. Maybe next. Next, okay. So 4 criteria resistant to mechanical loading. We have to, number 1, ensure proper manufacturing of the material itself. We have to have sufficient thickness and also proper maintenance of the gas cylinder. Okay, the cylinder valve has to ensure that it has ability to withstand high impact, and also the valve protection, if used, should follow ISO 11117. Okay, gas compatibility is, as I said just now, 114 identifies the material used for cylinders according to the gas stream. 1114 part 2 is for the valve itself. Okay, because normally valves are made in brass and not steel. There are steel valves for certain material, gas material, but predominantly majority of the valves are actually brass. Okay, retains pressure. Okay, so there is leak testing. I would go through a bit later on ISO 13341. and also endurance testing of valve, which is ISO 10297. Resistance of corrosion is another criteria. In our Malaysian environment, we have a condition whereby moisture is a key issue. Therefore, protection of the cylinder, keeping the internals dry, is very, very important. Next big one. Just a bit of history about construction of materials for gas cylinders. 1940s, we started off with carbon steel. Then 1940s to 1960s are common manganese steel, then chromium molybdenum. These are the what you call the components added to the cylinder, and what the industry or manufacturers call during the phase of the progress of the cylinders that they are manufacturing. Then right now for 300 bar cylinders, we have modified chromium molybdenum, which can withstand up to 300 bar they use. Aluminium alloy composites are also a type of cylinders that are right now in the industry. Composites are used and aluminium are used because of their lightweight. Other such as stainless steel, Monel, very expensive materials are for very specialized use in term for gases, majority for electronics. Manufacturing methods, seamless can go up to 400 bar, welded up to 100. Composites can go up to 450. These are composites, meaning fiber wrap cylinders. I'll go through a bit in detail afterwards. Next. Okay, carbon steel, most common, is the heaviest of all the cylinder types. It's used for hydrogen and its mixtures, but the material compatibility needs to be, composition needs to be looked at. It needs to be able to withstand sustain induced cracking due to hydrogen embrittlement. Okay, so there's a special component that needs to be added into while manufacturing this cylinders in the material. It's vulnerable to corrosion from moisture. Not recommended for CO and CO2 traffic. Okay. RPV or NRV valves, I'll go through it a bit later as well. This is recommended to be used to ensure minimum corrosion internally due to ingress of air and moisture. Next. Okay, carbon steel cylinders, corrosion. It's very important for us to keep the internal cylinder dry. Production processes are important to ensure that the gas that we put in the cylinders are safe. The higher, what we have found is that the higher the pressure, the higher strength of steel that is used, the more subjective, or more easier for it to be affected in terms of corrosion. Okay. Aluminium cylinders, although good against moisture, needs to be careful against acidic liquids, such as cola syrups, like Coca-Cola backflowing into a cylinder, and then mixing with the CO2 gas itself. It creates carbonic acid that causes internal corrosion. Okay, some photos below that you can see due to internal corrosion. The bottom two is due to moisture, okay, ingress, and the right one is on the aluminium cylinder due to carbonic acid corrosion. Okay, next. There are two types of steel cylinders, carbon steel cylinders. One is manufactured from a billet and another one from tube. Both are accepted under MS2542. It's just to show the difference in terms of the thickness when they actually roll the cylinders to seal the bottom end. Okay, just for information. Yeah, next. Okay, stress corrosion cracking. Carbon monoxide. Why we do not recommend the use of carbon steel cylinders on CO gas stream is because of the risk of stress corrosion cracking. Excuse me. So there will be actually transgranular cracking appearing in the material itself that reduces the what you call the effective efficiency in terms of the cylinder handling the stress. Okay. Next big one. Aluminium cylinders normally used since the 1950s, majority in military. After that, it was moved to be used in beverage, in scuba and firefighting rescue because of its lightweight. It's 1/3 the weight of steel. Okay, but generally more expensive, 3 to 4 times more expensive. It is good for corrosion that affects steel, but as said, moisture and acidic solutions are an issue. Heat is also a problem. Therefore, plastic test rings need to be used to detect if in case the cylinder has been subjected to heat. The normal temperature we would control it is around 80 degrees C. So even if we feel, we handle, we put it in the outdoor environment, we would normally put it in the shade. In the sun is okay because the heat on the sun on the cylinder will normally bring it up to about 60 odd degrees C at the most. Bear in mind that some cylinders are what you call, they need to be monitored against stress corrosion cracking for some materials of aluminium. Okay, next big one. Okay, composite cylinders, fiber wrap cylinders used in are the latest technology. Okay, they have limited life of 15 to 25 years. They are actually plastic lined cylinders with internal what you call internal stainless steel, normally stainless steel, okay, wrapped externally with a fiber. So these are very, very light, can withstand very, very high pressures, normally for above 300 bar. But because the wrap, the fiber wrap is important to as an encasement, therefore additional care needs to be taken when handling and also these cylinders. Okay, next. Okay, MS2542, the reference standard that we are using in terms the base standard, I could better term it that way. The base standard that we are using for manufacturing of cylinders is basically MS ISO 9809. This is reverse engineered from, I would say not reverse engineered, but adopted from ISO 9809. It was developed in 1999. And it covers the design, prototype testing, and the mechanical testing of cylinders. Pressure test cycles during the for the batch testing requirements is up to 12,000 types. This would normally cover the entire lifespan of the cylinder. Lifespan of cylinders, as where we are experiencing cylinders right now that last for 70 years, 60 years, 70 years. So 12,000 cycles normally covers that entire period. Okay, bear in mind the testing requirements needs to be maintained as well during while the cylinder is in operation. There's hydraulic burst test requirements, mechanical hardness tests. After that, there is actually a leak test, water capacity check, and also the stamping requirements. Talk about stamping requirements in the next few slides. Next. So stamping requirements, AGA 3605 is the catalog of all the stamps that are, I would say, is not exhaustive, but it covers majority of the stamps that can be found throughout the world. So as you know, Malaysia, there is no gas cylinder manufacturer here. So we are importing and bringing in cylinders throughout the entire cycle, and therefore this document provides a guideline on what are the stem markings on the cylinder that can first be used for visual representation of for a safe cylinder. Yeah, one note of caution is that these stem markings need to be substantiated with testing records. Okay, next. Okay, so after the cylinder, the manufacturing process, the difference in terms of the type of cylinders, we go on to the gas cylinder valves. Okay, so it's used to seal the gas in. It needs to resist corrosion, allows flow of gas, and also controls the flow to a certain limit. It protects the cylinder from internal contamination. RPV valves lasts for a long time. Experience in the industry shows that 30 years so far is the limit. Okay, and it needs to resist abuse from users, majority. Okay, thanks. Okay, there are types of valve there's two main categories, which is basic and then basic simple valve and complex valves. I'll go through the terminology between these two later. Materials, copper, stainless steel, copper alloy, brass predominantly are the valves that is used. Stainless steel, nickel, carbon, and as well as aluminum alloys that are very rarely used. Again, reference is to ISO 1114 for valve compatibility. Actually, it's part 2. Sorry, typo error here. Next. Inlet valve. Okay, so this is generally how a side outlet pressure retaining valve looks like. Okay, there is an inlet. Okay, which is where the what you call the valve is connected to the gas cylinder itself. Then there is a shank. The shank is actually the threaded point, threaded bottom that you can see at the valve. There's actually parallel, which is on the right hand side, and also tapered. Tapered has an angle to it, okay. So the only thing that is to observe here is for tapered, we put PTFE tape around the thread. For parallel, there must not be any what you call the PTFE tape around it, because as we screw the valve in, the PTFE will compress and push up. That will push the O-ring, compress the O-ring, which might not tighten the gas clearly. Okay, so PTFE is not used for parallel thread valves. Okay, next. Torque limit is important depending on the material of the valve and also the cylinder. A different torque would actually damage either the cylinder neck or weaken the valve by stretching and then work hardening the brass itself, brass valve. Okay. I wouldn't want, yeah, you'll be able to see that there is a different torque limits for the valves. Okay, next. So there's two types. There's side outlet and top outlet. For top outlet valves, it is facing upwards. Side outlet is facing the side. From the image, you can see. 5 valve outlets are locally regulated, and we actually have to align to the codes and practices. Okay, for the gas, according to the gas group. This to avoid confusion of the gas filling itself, gas filling, and also for user. So oxidizing has a different connection versus a flammable gas connection. Okay, so flammable has what we call a left-hand thread, which is flammable has a left-hand thread, which is what we call anti-clockwise movement, while a clockwise movement is for what you call for oxidizing valves and inert valves. So there is no way to mix up these two together. Other connections such as pin index for medical use is available as well. Next slide would be for medical. medical pin index has its own address, what we call address of the pin to the valve. We call the valve the yoke. That will allow us to ensure that the equipment that we connect to for the medical use does not have a wrong gas. The type of connections can be seen in the bottom four images there. There is a Malaysian standard, which is MS ISO 407, that controls this use of the gas type according to the address. Next slide. Okay, so going back to the valves again, there's two types, what we call a simple valve design and an RPV valve design. So for simple valve design, the breakdown of the components are that you have the body, you have the inlet connection and the outlet connection, and also the operating mechanism, which is the hand wheel, the spindle, and the seals. Okay, the seal and seat combination can be either metal or soft, what we call soft seat. Majority of the industry is for soft seat. That we use for seat. Very, very seldom metal seats are used. Okay, but for certain gases, metal seats are used. The spindle can either be a single part, yes, or two parts. In our industry, normally it is two parts. For the newer valve designs, it is the two parts. Okay, next, pick one. RPV, or more complex. Why we call it RPV, MPR is to retain the positive pressure in the cylinder itself, so that when the gas is used, a certain amount of pressure, roughly about 3 to 5 bar, is maintained inside the cylinder. To fill this valves, a special pin needs to be inserted at the filling connection head. If you see in the image here at the valve outlet right hand image, there's actually a pin image and also a shutter and also a spring on the right hand side at the RPV cassette. This one stops the gas flow when the pressure drops below a certain level. Okay, there is a benefit here, as in the cylinders can be top filled because the gas inside the cylinder is maintained. Of course, additional checks need to ensure that the function of the valve is actually operating well before it's sent in for refilling. Okay, as you can see, it's because there's like a check valve, it prevents the gas from actually flowing back into the cylinder. Okay, next. So the standards of the valve that we adopt in Malaysia is MS ISO 10297. It is referenced in 2542 as well. MS ISO 10297 is actually a combination of standards. You can see EN, CGA, DIN, AS is also inside there. The testing of the valves follow protocols identified here. I've put in some examples of ISO 10297, EN 849 as the test standards that is being used. Okay, next. We'll go through the test standards. So some images of how the testing are done. Okay. The tests are done to ensure that the design of valve has sufficient inherent strength to withstand the impacts during transit or subject to certain abuse. It might not be abuse, it could be an accident, a cylinder falling, things like that. So this test is to ensure that the valve can withstand that fall or that abuse. Okay, so for industrial range valves, they test it to roughly about 200 joules, point test. The top right picture shows that impact, that press that is being done. It also needs to pass through a test of leakage to ensure that it is gas tight and does not leak. Okay, next. This is a test pressure that is adopted in the standard. Okay, so compressed gas is 1.5 times 1.2 working pressure. Liquefied has another criteria. dissolved acetylene is fixed to 450. Test temperature is identified inside there at this relevant. Plus minus 5 degrees of 20 is within, I would say slightly lower, but within the environment that we're working in. Yeah, and it needs to last for 2 minutes. Next. Okay, there is also what we call a flame impeachment test, whereby they subject the valve to high heat and a flame. It's very, very high temperature for a short burst period of for 1 minute to see whether it can withstand the temperature. After that, it is cooled down and tested again to see that it is to ensure that the valve has still capability to subfunction. What we call subfunction, as it can be closed. Okay. Gas cylinder valve top testing. This is to ensure that if the valve is subjected to a high torque, it does not break catastrophically. So this test here identifies that criteria, provides a criteria of how the testing needs to be done to ensure that even though there is an over torquing, the valve does not shear. Okay, that's just a brief on it. Next, big one. Type testing. Okay, also covers the pressure leaking of tightness to test the pressure leaking of the valve itself. Sorry for the this one is actually for leak testing. Okay, so leakage rate is tested to ensure gases such as flammable and toxic seals in the seals in the cylinder itself, and it does not leak out to the environment. So this test requirement covers that process. Okay, next. I'm a bit slow on the time. There's also endurance testing on the valve. Okay, endurance testing is the cyclic effect that we will subject the valve to, how many times opening and closing of the valve. That relates to the number of cycles, which relates to the years of how long the valve can be in service. So the testing of how many times opening and closing will confirm the durability of the valve in that period of time. Bearing in mind that there is also an age of polymer of the valve itself. So that age of the polymer subjects the valve to scheduled maintenance, which is covered under MS 2542 under substandard category of the standard itself. Okay, next. Okay, this one which is more relevant to our industry, cylinders fall. So as a cylinder falls, gas cylinder falls, the valve will be subjected to a certain shock. Okay, so this shock needs, during that shock process, the valve needs to be able to withstand that criteria. The test identifies that it needs to go through 10 times that tip over test. Okay, so which is, I would say, very, it's a practical way for us to identify whether it can withstand or not. Okay, next. Salt spray test. Our cylinders go through an environment whereby it goes into a condition whereby we are subjected to the sea environment. So neutral salt spray test will identify whether if the material, salt or what we call chemicals will subject the cylinder to pitting, okay, or corrosion. Okay, after this time, the cylinder valve is actually taken out. After this test, the cylinder valve is actually taken out. We actually do a micrographic examination to identify the material, the corrosion on the surface itself, to see how much it has actually pitted or eaten into the valve material itself. So that amount of pitting will identify whether if it is able to withstand the corrosion or not. Next big one. Adiabatic testing is used for oxygen valves, is to test the impact of oxygen after a certain stop of the gas. As you know, oxygen goes through, what we call auto ignite at a compressibility, at the gas compressibility on its own. So this test is to identify that if there is an emergency and there's an abrupt close of the cylinder valve during the gas stream where oxygen actually travel, the valve can actually withstand and take that particular impact and heat and dissipate it through the valve body itself. Okay, this test is conducted 50 times of cycle. Okay, next. Okay, valve protection. Next big one. Next, so some images of cylinder valve guards and protection that is used in the industry. Okay, so for cylinder valves that meet MS2542, in the standard is identified as not mandatory to have a valve guard protection. It should be applied depending on the risk assessment of how the cylinders are handled, and also the environment that it is subjected to, the gas cylinder is subjected to. So in certain conditions that are at high risk, whereby a fall is a high risk, then of course valve protection needs to be used. These are some, on the right hand side, are some examples of valve protections that are used in the industry. There are metal and also plastic type of valves that is used in the industry. Okay, so an image of how a valve protection should be, it should cover the entire valve itself, okay, in terms of its radius and also the height. It should not expose any part of the valve in any way when the protection is up. Okay, so for valve protection, this is the test that is done. They actually do a torque, axial, and also a drop test on the valve itself to ensure that the valve can withstand. The standard that is adopted is EN 962. Okay. Next big one. So a top test is to ensure that the valve guard interfacing with the neck of the cylinder does not come off. Okay, is to ensure that it grips at a particular moment when it actually falls and it doesn't come off and then affect other things. There's also an axial test to test the mechanical strength of the valve protection. Okay, and also a drop test. Just now the image actually shows to drop it to see how actually it takes the damage and also the impact. So okay, I think that's yeah, that's all. Slightly above the time. Okay, thank you, everybody.
Okay, thank you, Anthony, for your presentation on the MS 2542 2013. We'll move on to the next presentation, which is on a topic on ASU process and cold box design. This will be presented by Ms. Jesselyn Tan of Asia Industrial Gases Association, AIGA. And just a brief introduction of Jesselyn. She is currently a process safety engineer for Southeast Asia Cluster Large Industry of Air Liquide. Her previous work experiences include as a technical risk and safety consultant in oil and gas industry, as an on-site engineer in power plant, and also safety engineer in a catalyst plant. With that, pass the floor to Jesselyn for her presentation.
All right, thanks, Pat Wan, for the intro. Selamat pagi Tuan Haji, Tuan-Tuan and Puan-Puan. So my section today is divided in two parts. First is a brief intro of ASU processes, and second is the basic safety features, operation and maintenance for cold box. We will not focus on COBOX design today due to privacy issues for each company. However, please note that most incidents involving ASU and COBOX are usually initiated by poor operation and maintenance, but not the design of the COBOX. Next slide, please. All right, so we will start with the ASU intro. As we all know, our air consists of 78% nitrogen and 21% oxygen. Other than these two, we have 0.93% argon, and the remaining is traces of gases and moisture. So ASU stands for Air Separation Unit. Most ASU separate nitrogen and O2 from the air, while some separate argon too. Air separation process is based on the fact that O2, N2, and argon can change into liquid phase at different boiling points. It's easier to separate them out from air in liquid as compared to gas. Liquid product also allows us to store more products as compared to gas form. So the boiling points for these three gases are extremely low and close to each other. They are commonly produced together in ASU. For instance, nitrogen boils at -196 degrees Celsius, argon at -186, and oxygen at -183. So what are the main air separation processes? Let's take a look at the video. Back one, please.
First, air from the atmosphere is suctioned and filtered using filters to remove dust particles and other hard impurities. Then compressed in a 6-bar pressure to make the air flow from start to end of the process. If the air is
Sorry, are you able to see the video?
air molecules.
We cannot see the video. Yeah.
Oh, I'm sorry.
At high temperature is cooled in the pre-cooling system to around 10 degrees Celsius using refrigerated water. During this cooling process, carbon dioxide and which is not required for us. Water, hydrocarbons, and carbon dioxide are removed in the purification units.
Yep, it's
using
okay now.
molecular sieves and activated alumina. Carbon dioxide atmosphere is filtered using to remove dust particles and other hard impurities. Then filtered air is compressed in a compressor, up to 6-bar pressure, to make the air flow from start to end of the process. If the air is compressed, then temperature will increase due to increase in kinetic energy of air molecules. So, the high-pressure air, at high temperature is cooled in the pre-cooling system, to around 10 degrees Celsius, using refrigerated water. During this cooling process, air will capture additional moisture, as it is in direct contact with water. So at this stage, high pressure, low temperature air is having impurities like water, carbon dioxide and hydrocarbons, which is not required for us. Water, hydrocarbons, and carbon dioxide are removed in the purification units, using molecular sieves and activated alumina. If water and carbon dioxide are not removed, then they will form ice in the lines, and results in blockage of the air path. If hydrocarbons are not removed, then it will result in explosion, if it accumulates in. Now, at this stage low temperature, high pressure air is having only oxygen gone. This high pressure air is then expanded in a Joule-Thomson valve. This adiabatic expansion results in drastic drop in temperature from 10 degrees Celsius to -120 degrees Celsius. Then, this expanded air is passed to fractional distillation column. Cold air through heat exchanger and fractional distillation column. Air temperature is -165 degrees Celsius. At this temperature, air inside the fractional column will get liquefied, and this liquefied air is having 40% content as oxygen. This liquid is called as rich liquid, as oxygen is taken and given as reflux at the middle of fractional distillation column. This cold, rich liquid and this vapor will get and remaining nitrogen will escape to top. This is because nitrogen is having lower boiling point than oxygen. This process is similar to the condensation process happening at vessel having boiling water when closed with a lid at the because of lid chillness, escaping water vapor will get condensed. Distillation column. Cold reflux will act as the lid. To have proper contact and inside distillation column, trays will be kept. Some of trays, packings are also hence proper heat by repeating this process for long time, the temperature gradient from bottom of the distillation column to the top. From -170 degrees Celsius at bottom of the column to -1 degrees Celsius at the top of the distillation. Because of this temperature gradient, oxygen will be liquefied at -183 degrees Celsius area and collected. Argon, -186 degrees Celsius area and collected. The top temperature is at -196 degrees Celsius and collected. Normally, height of this distillation column will be around 40 meters, depending on the production capacity of the oxygen plant. Oxygen produced, using the technology will be having a purity of 99.5%. The liquid oxygen produced can be taken as liquid product, and stored in insulated cryogenic vessels. Later, it can be transported and converted to gas using vaporizer coils. This gaseous oxygen can be for distribution to end users. Percentage of transportation in liquid mode is 1 meter cube of liquid can be converted to gaseous oxygen of 700 meter cube. Thanks for watching our video. Subscribe to our channel if you like to access more such educational animated videos. Thank you.
So thanks, One.
First,
We will go for the next slide.
And filtered using filters to remove dust
Sorry, hold on a
and
second.
other hard impurities. Filtered air is compressor up to 6 bar pressure to make the air flow from start to end of the process. If the air is compressed,
We can start with slide 5.
Yeah, okay.
Okay. Yes, this slide. Okay, thanks. Okay, so what are the major process? This slide actually shows the main ASU processes which we went through the video just now. It starts with ambient air filtration, then the air is compressed to about 6 bar for easier liquefaction, followed by pre-air cooling and air purification to remove moisture and CO2. The air is then further cooled by the heat exchanger and turbine or expander to the required boiling points at about -170 degrees Celsius. So before entering the distillation columns to separate out both liquid and gaseous O2, N2, and argon. So liquid products will be stored in the tanks, while gaseous products can be delivered straight to client with or without compressor. Next slide, please. All right, so what are the major process safety hazards for ASU? First is an oxygen hazard. Oxygen is not flammable but accelerates combustion. When it's more than 23.5%, non-flammable materials can burn very rapidly. More than 40%, flash fire occur easily. So ASU produces high concentrated O2 in both gaseous and liquid form. It can be easily more than 40%. So O2 enriched atmosphere could happen from leaking pipe or flanges, overpressure release, desorption from adsorbent from the purification unit and insulating material, evaporation from cryo-liquid spillage, and etc. It's also important that all equipment and pipings used for oxygen services and system is cleaned properly before startup, because some organic contaminants such as grease and oil can ignite fire easily with the presence of high O2 concentration. Next hazard is asphyxiation, because leakage of nitrogen or argon can create O2 deficiency atmosphere in both enclosed and open area. Less than 12% O2, human will be unconscious without any warning. Third hazard is a warm and cold embitterment. As you all know, ASU process is around negative 170 to 190 degrees Celsius. So carbon steel is not suitable for temperature less than negative 29 degrees Celsius because it can break easily. So most common compatible metals for cold processes in ASU is authentic stainless steel. Others are aluminium, copper, manganese, brass, and etc. So it's important to ensure the right material is used for cold processes. Carbon steel can only be used for warm pipelines outside the cold box, but need to ensure no cold liquid or gas flow into these pipelines. Next hazard is hydrocarbon accumulation in liquid oxygen bath. So ASU itself has no hydrocarbon in the process, but hydrocarbon might enter into ASU through the air from neighboring plant release or haze from forest burning or leaking lube oil from machines such as a turbine. If hydrocarbon enters into ASU and start accumulating in high O2 liquid with vaporization, explosion might occur. Hence, it's very important to prevent the entrance of hydrocarbon. For example, you can install some filter and proper lube oil leakage monitoring system. So it's also important to ensure there's no plugging or dry boiling, which could accumulate hydrocarbon in ASU. Last is a pressure hazard. It could be overpressure or under pressure. This could happen in cryo-liquid storage tank or vessel or distillation columns. Pressure hazard could lead to pipe rupture, vessel burst, or ejection. So pressure monitoring systems such as a pressure control loop and pressure relief devices are very important. Next slide, please. All right, so this slide highlights the precautions for us to manage the major process safety hazards for ASU. Always know the right PPE for each task. Always understand the hazards and its consequences to human prior to any task. Be aware of oxygen service equipment, piping system. Must be clear, must be cleaned and operated based on specific O2 service SOP. MOC SOP must be respected whenever there's a change, and always be aware of possible asphyxiation hazards. Next slide, please. All right, so next we will start the second part of the presentation, which is intro to cold box. Cold box is like a fridge, which main purpose is to maintain the cold inside the cold box with insulation such as mostly it's perlite to prevent heat from outside entering into the cold box. Common items inside the tall cold box is usually distillation columns, such as the O2 column, N2 column, argon column, or heat exchangers. Material used in the cold box can be stainless steel for distillation columns and pipings inside the cold box and bottom of the cold box casing. Carbon steel can be used for the external cold box casing and piping outside the cold box only. Next slide, please. All right, items inside the ASU distillation column cold boxes are usually designed with welded joints and no flange or thread connection to prevent internal leakage. All joints are usually 100% inspected, assembled through radiography, helium tests, pressure tests, and etc. Usually no rotating equipment inside the distillation cold box, so opening the cold box for routine inspection is generally not advised or required. So cold boxes are usually designed for long operating period based on global best practice, provided they are operated and maintained as per the manufacturer recommendations. There are currently hundreds of cold boxes operating for more than 30 to 50 years in the world. So cold box modifications are generally not allowed or encouraged without consent or authorization from competent party, such as a ASU manufacturer, competent designer or expert in the company or third party. Next slide, please. So this is a tall cold box, how a tall cold box looks like with distillation columns inside. Typical designs are square and round type with and without frame. Next slide. All right, this photo shows the internal of the cold box during construction. So if you look at the tall cold box, which is opened up with two columns inside, so those two columns are actually the distillation columns, can be a nitrogen column or argon column or oxygen column. Next slide, please. All right, so next we will go through the safe operation of cold box. It's essential to ensure the atmosphere inside the cold box is monitored closely and within normal range. For example, the purged gas pressure, flow, and composition, as purged gas is usually injected into the cold box continuously. Manufacturer SOP shall be available for different operating and maintenance mode, including warm startup, cold startup, normal operation, cold shutdown, warm shutdown, and also recommendation for periodic inspection and maintenance of the cold box. Next, please. All right, so next we will brief through some process safety incidents involving poor cold box management. So what happened over here, this is actually about the presence of ice block inside the cold box. The ice block is not detected before plant startup. As a result, during warm startup, the ice block in the cold box limits space for piping thermal expansion. This led to pipe bursts and leakage occur in the cold box. Eventually, the plant could not start up and need to shut down. The major causes of ice block formation inside the cold box is due to moisture and from the air enters into the cold box. So how did moisture ingress occur? This was due to insufficient cold box nitrogen purge lead to insufficient positive pressure inside the cold box. As a result, higher atmospheric pressure causes the water to enter through the cracks and holes on the roof or casing panels with lack of corrosion control. Next slide, please. All right, so lesson learned over here is a poor maintenance of the cold box over the years. Corrosion control inspection and ice block detection inspection are neglected. Inadequate N2 purging of the cold box. So what actions can be taken? First is periodic N2 purging flow monitoring to ensure inside the cold box there's always positive pressure. If low pressure is detected in the cold box, it might indicate moisture in the air have possibility to enter the cold box. Second is the periodic ice block checks on the outer side of the cold box casing shall be performed. This is because the ice spot could indicate the possibility of ice block in the cold box. If ice spot is detected, site can take pictures of the location and size of the spots, then do a mapping over time to confirm whether it's a real ice block with an expert and decide what monitoring or mitigation plan could be taken. So third is a periodic inspection of the perlite level. The decrease of the level could indicate something wrong. Fourth is ensure the safety blow-off devices such as the weighted disc on top of the cold box can move freely and are not obstructed by ice or paint. Fifth is a visual inspection of cold box roof. Sixth is applied paint or primer during a plant turnaround where rested area are warm and free of ice or condensate. Seven is to refer to the cold box inspection checklist from IGA Safety Bulletin 22/20. So we will further discuss this in the upcoming slide. Next slide, please. All right, second incident. So what happened was the perlite in the cold box was removed to allow local pressure vessel inspector to inspect the vessel in the cold box. An experienced contractor was engaged and they decided to remove the perlite from the bottom of the cold box, not from the top as required by the SOP. Perlite removal at the bottom caused a steep slope of perlite from the cold box. The perlite is then collapsed, generating a force that lifts the cold box relief devices, relief valve, and release the perlite into the environment. So perlite release can be hazardous to both environment and human. If there's any internal process leakage saturated in the perlite, large cloud of O2 and 2 or argon can form from rapid vaporization. from the perlite. So due to the safety concerns of a possible perlite release from deperlighting activity and also the possibility of moisture ingress into the cold box, ASU manufacturers generally would not advise opening the cold box for periodic inspection. It will only be done if there's unexpected leak due to improper monitoring and operation. Next slide, please. All right, so what can we do to ensure safe operation of cold box? First, we need to ensure the periodic inspection of the safety control devices to manage the major process safety hazards, as most past incidents of ASU are from this process hazard, not the cold box design itself. For example, the safety control loop for hydrocarbon hazard management, including CO2 monitoring, rich O2 liquid bath level monitoring, loop oil leakage detection, overpressure, under pressure protection loop, pressure relief devices, low temperature protection loop to prevent cold abutment, tank spillage, overflow detection, pump cavitation protection, and etc. So second is M2 purging in the cold box. This is a very important barrier. We will further discuss in next slide. So third is cold box overpressure protection through pressure relief devices such as a weighted disc or hinge lift plates at the top or side of the cold box casing. Fourth is periodic cold box integrity inspection and maintenance. We will further discuss this later on also. So fifth is to highlight the occupational safety of perlite handling tasks, such as a perlite filling or removal. Specific procedure JHA work permit is required to prevent personnel from falling into the perlite and cause asphyxiation. So lastly, it's very important to have emergency response plan drafted and implemented for major perlite release or cold box damage incident. Next slide, please. So why M2 purging system in the cold box is very important. So main purpose is to ensure a positive pressure in the cold box to prevent moisture in the air from entering the cold box and form ice block, like what happened in the first incident we discussed previously. The N2 blanketing system is a continuous N2 injection system into the cold box to make up for any N2 losses from the leaks or venting. The cold box needs to have a venting system to prevent overpressure and accumulation of hazardous gases. It can be of a weighted disc to maintain a back pressure on the enclosure. So sample points at different height of the cold box shall be available to allow complete periodic inspection. M2 purging shall be distributed evenly throughout the whole height of the cold box via a distribution system shown in the picture on the left. Next slide, please. Right. So this slide is to discuss what needs to be inspected and maintained periodically to ensure the safety of the cold box. First is to have the temperature check at the bottom of the cold box to ensure the required temperature is maintained and no leakage. Second is to draft procedures for operator response when safety alarms are activated. Third is a periodic monitoring of sample pots to ensure proper purging in the cold box. These sample pots shall be located at different heights throughout the cold box. And fourth is a continuous O2 detectors complete with SOP for monthly inspection. Fifth is a visual inspection for eye spot on the cold box casing. All these inspections are important as they help the site to identify initial abnormal conditions in the cold box and allows the site to have enough time to plan for mitigation or monitoring or repair before it escalates to a major accident. Next slide, please. All right, this slide shows a list of IGA, EGA standard available to guide safe operation and maintenance of cold box, including periodic inspection. You can click on the link here at the bottom to go to IGA publication website for more references. These guidelines are free for download. Next slide, please. All right, so next we have the cold box periodic inspection checklist from IGA Safety Bulletin 22/20. So I have attached the link over here also in the blue color. So basically the important points over here, we have already explained previously. However, I will still briefly go through the list below. So first is a cold box pressure, such as the nitrogen purging pressure, needs to be regularly recorded. Checks for any abnormal ice patches at the cold box casing. our gas sample being taken from 4 spots area for analyzing is this vent to safely waft exhaust vent to a safe place? Are this vent free from obstruction? Is the vent vented at open area and right height for better ventilation? Is the vent piping free of blockage from ice and etc.? It's also important to make sure the pressure relief devices such as the pressure relief valve and weighted disc on top of the cold box casing are not stuck with paint and ice. So are the cold box foundation temperatures checked at regular intervals? Do liquid drain lines slope downhill into disposal header? Any cryo liquid accumulation at the drain lines? For derailment operations, are procedures followed and inspections are recorded to ensure that all drain and instrument lines are free from moisture? Are all the asphyxiation warning signs installed at all high-risk area? And is insulation material used on cold piping in good order and dry? Next slide, please. Right. So in summary, ASU cold boxes are designed and operated as per globally established best practices and harmonized standards. We can refer to manufacturers' instructions and also IGA cold box checklist SB 22/20 to ensure proper operation and maintenance of the cold box. So this checklist is actually developed based on globally harmonized practices, including USA, Europe, and Asia. All right, next. Yeah. So these are the disclaimer from IGA for using the checklist. All right, so that's all for my presentation. Thank you.
Thank you, Jasmine, for sharing on the ASU process and also cold box design. Ladies and gentlemen, we will stop the presentation for a while, but if you have questions to our first two speakers, please remember to post a question on the Q&A function on the webinar platform. Okay, now the next item in our agenda is a quiz session. So to participate in the quiz session, you can use your mobile phone to scan the QR code below to join the quiz section. Or if you are not sure how to use the mobile phone to scan the QR code, you can also access the Mentimeter website at www.menti.com and enter the code 88116743 onto that web page. So it will bring you to that quiz session page. Liani, do we have the numbers on the?
Yes, right now it's 17.
70. Is it?
17.
Oh, 17. Okay, we'll wait for more for a while first.
We have about 40 participants now.
Okay.
Any more coming in?
Ellie, maybe just start lah. Due to the
Okay.
time constraint.
All right. Hold on, ah.
I'll stop sharing the screen. Ms. Ilyani Ahmad from our technical committee will handle this quiz session.
All right. Hold on. Okay. All right, we start with the first questions. There's 5 questions. All right. The first question. Look at your phone. Which of the following are critical for safe cool box operations? This one is from the Jocelyn speakers just now. Which one is the answers? Periodic inspection of nitrogen purging of cool box foundation temperature check at regular intervals. All answers are correct. Periodic maintenance for safety critical devices. All right, 1. What's the answers? All right, we have 29. All answers correct. Okay, all the answers are correct. That's the answer. All right, who is the leading? Watson. I believe so, Watson. All right, good. Okay, next questions. Second questions. Look at your phone. Why do ASU manufacturers generally will not advise opening the cool box for periodic inspections? Fear of a light release, moisture increase could lead to ice block formation in the cool box, or fear of exhaustion, or all the answers are correct. 5, 4, 3, 2, 1. All right, what's the answer? All right, most of you got it correct. All answers are correct. Okay, who's leading? All right, we have a new lead, Zahrin. Okay, next questions. What is the main purpose for nitrogen purging of the cool box? To ensure a positive pressure inside the cool box casing, to prevent corrosions, to maintain the temperature, to ensure no increase of flammable gas into cool box. All right, 5, 4, 3, 2, 1. What's the answer? All right, did you get it right? To ensure a positive pressure inside the cool box. Okay, next. Who's leading? Looks like new lead. All right. Barefoot Contessa. All right. Next. Question number 4. This is regarding Anthony's slide just now. Which of the following is part of the gas cylinder package? Gas cylinder and valve, manifold, valve rotations, or all answers are correct? Four, 3, 2, 1. So what is the answer? Did you get it correctly? Yes, most of you get it correct. All answers are correct. All right, who's lead? All right. Sarah. Okay, last one. Also regarding Anthony's slide just now, which of the following statement is true in MS 2542 2013? Ensure a copy of the test certificate are maintained. Need to satisfy I got 3909. All answers are correct. Need to satisfy the next 4. Did you guys get correctly? Time's up. Are you sure? There's a lot of tricky answers there. Okay, the answer is ensure a copy of the test certificate are maintained. All right. That's all. Who's the winner? Sarah. Okay. We don't have a prizes for you, but you can be proud that you did answer it, most of answers correctly. That's all from me. That one, pass to you.
Thank you, Iliani, for facilitating the quiz session. And thank you to all participants for your active participation in this quiz session. So we will continue with our presentation for the workshop. So the third topic of the day will be on acetylene cylinder and safety incident, which will be presented by Mr. Elvin Tam of AIGA. A brief introduction of Mr. Elvin Tam before we start. He is currently the Engineering Manager, PG Asia of Air Products Singapore. He has 20 years of experience in the industrial gases application. His area of expertise include packaged gas engineering, equipment and processes. He is also currently a member of the packaged gases work group and also medical gases work group of AIGA, and also a technical committee member of the Industrial Gases Association Singapore. So I pass the floor to Elvin.
Right. Thank you, big one. Okay. Let me start. You can see from the screen, I would like to have a disclaimer page first. The contents that I'm going to share later in my slide been available in AIGA's website, and a couple of information actually come from all the AIGA members company. Information have been shared, but however, AIGA do not hold any liability or responsibility in terms of connections with the reference. At the end of the slide, you feel free to download the reference documents from AIGA website. Right. Next page. With my slide today, this is the number of agenda. All right. First one, we will go through the acetylene cylinders, acetylene's property. Acetylene hazards majority involve flammable risk. Past accidents involve acetylenes. Identifying major hazard at workplace that involve with acetylene and its applications. Acetylene cylinder storage, safe transportation of acetylene cylinders. That is the 7 major agenda that I'm going to share. Next slide, please. Right. Let us have a bit of a basic understanding how does acetylene cylinders been structured. As we know, acetylene is a well-known gas, or so-called a fuel gas that able to use for cuttings, welding, for general public. However, acetylene itself could be very reactive if it's contained in empty cylinders. So over here, I want to share with the member today is that acetylene cylinder is a kind of difference from the normal industrial gas cylinders, which is basically it's empty, but acetylene cylinders itself is being contained, we call it a porous mass. You can see from the cross section at the bottom right-hand corner, that is section out of acetylene cylinders. So basically inside there, this porous material will fill up the internal of a steel shell cylinders, right? It's a steel, is normally it's a carbon steel shell cylinders, and there are this porous mass that will actually fill up the whole internal of the cylinder. Acetylene gas is actually able to be captured into this porous mass. Just imagine this porous mass is more like a sponge, right? It's more like a sponge. You have a lot of pocket in there. When acetylene gas is being filled into these cylinders, there are these solvent. Normally, we will have it as a acetone or a DMF solvent. This solvent is added to like an absorber, a liquid that actually would capture the acetylene inside this porous material, right? Acetylene cylinders are designed to safely contain acetylene with a test pressure typically 1.5 times of the nominal working pressure. All right, and of course, the periodic test periods for acetylene cylinder are being divided by relevance country regulations. Probably in Malaysia, there will be under MS standard requirements where that define the periodic inspection and maintenance of acetylene cylinders. So for acetylene cylinders, they can be in a single cylinder, or it can be actually combined into bundle, which is in the number of 6 to 16 cylinders being manifold together. So typically we see is that 6 configurations are commonly seen in the industry. Important informations of the cylinders are normally being stamped or engraved on the cylinder shoulder. What is in there will be like the test date, the weight of the cylinders, and the volume of the cylinder are all being stamped on the cylinder shoulder. The common manufacturing standard for acetylene cylinder are ISO 3807. Right. If you look at the on the right hand side, there is a diagram that actually show the contents of the acetylene cylinder within acetylene cylinders. So technically, you can see that acetylene will be dissolved into this porous mass in a percentage of 33%. Right, the porous mass itself actually only take up 10% of the content of the cylinders. And you can see that acetone actually contain 42% of the contained volume, and there is only left about 15% of the space for expansion. So basically, you can understand that these porous mass material is more like a sponge. When you compress them, it's only take up 10% of the cylinder volume. And the acetone actually take up 42%, and then the dissolved acetylene is 33%, and this make up 100% of the acetylene cylinders containment. All right, next slide. Right, so acetylenes sometimes we call it DA. Why it is being called DA? It's called dissolved acetylene, and the chemical formula is C2H2. Acetylene is being supplied in cylinder with porous mass, and because it's been dissolved in the acetone. That's why it's been called as a dissolved acetylene, which is called in the short term called DA. Acetylene is commonly being used in combination with oxygen for cutting, heating, and welding our mouth steel, right? And this type of combination, normally we call it as a oxyacetylene cutting flame. And there's also special use application for a pure acetylene, which is more for the organic and chemical synthesis type of applications, but that is really high end. For general industrial oxyacetylene cutting application is the most common. Why is that the acetylene flames are more been preferred? Basically, is that the so-called the oxy flame give you the highest fuel temperature, so-called the flame temperature. You can imagine that when you see a flame that is deep blue in red color or orange color, the temperature range is go up to 600 degrees Celsius to 800 degrees Celsius. That is the normal blue, so-called the orange flame that generally we will see. But if you're looking at the left, so-called the right-hand side, there is three kind of flame, right? It's generated by acetylene with a mix of oxygens. You can see that we will call this as a blue flame. The blue flame is the deeper blue that it goes through. You create the highest temperature. And this type of blue flame, basically, you have a temperature range of 1,400 degrees Celsius to 1,650 degrees Celsius. Is how many times hotter than the normal, the orange flame or deep red flame that we use for cutting. All right, so that's why in steel industry, in general industry, acetylene with oxygens as a cutting fuels are very popular because it creates a much higher flame temperature, so that's for easy to make a cutting and heat treatment. Right. Next slide, please. Right, so we have some here is that I want to share with the material compatibility with acetylene. So for acetylene, there are some good material that actually are very compatible. It's like aluminiums, rubber, carbon steel, PVC for lower pressure, stainless steel, and Viton. Right. On the average compatibility, we have brass, KLF, and neoprene, nylon, and Teflon. These are very compatible. There are also material to be avoided, right? Do not use this type of material or with acetylene system, right? So copper is totally not compatible with acetylene. Bonaen, Monel. You can see that Monel are very compatible with oxygen, but Monel are not compatible with acetylene. Polyethylene, silver, and alloy that contain more than 70% of copper or 43% of silver. So silver and copper, they are very reactive with acetylene. They will create a very explosive or flammable byproducts. So normally we would not want to use pure copper or high content silver material that in contact with acetylenes. And also for help risk acetylene, you will create efficiencies and also have some form of analytic type of effects, which is remove kind of a mute any of the paint. Transportation code for acetylene ADR class 2 4F, and under the US is a DOT class 2.1. Acetylene by itself is colorless, and as you know that it is highly flammable, right? When there is an acetylene being released into the air, the first thing that we able to pick it up is by, you can sense that it's a kind of a garlic type of a smell, right? So when this type of a smell that is able to detect, that means there could be a possibility that is acetylene leakage nearby. And also acetylene can actually decompose instantly at a pressure higher than 1 bar. Later on, I will share what is the recommended maximum working pressure for oxyacetylene applications. So just take note, acetylenes would be very versatile when its pressure go higher than 1 bar. All right, and of course, I have been repeating myself is that acetylene being supplied in dissolved with acetone or DMF, right? So, and normally you can see that the acetylene cylinder, the pressure will be in the range of 15 to 17 bar at the reference temperature of 20 degrees Celsius. Auto emissions temperature for acetylene in air is 333 degrees Celsius. When there is an enriched oxygen enrichment environment, the auto ignition temperature would drop down to 300 degrees Celsius. Acetylene has a very wide flammable range. That means that in air conditions, acetylene will be in a very flammable range, is 2.3% to 83%. So when acetylene leak into the air, it will create a flammable range at 2.3 to 82%. When there is a rich oxygen environment, this acetylene flammable range would actually widen to 2.5% to 93% volume. That means that when there is acetylene leak into an environment that is also higher oxygen content, the chances for it to catch fire will be much higher. Right. Next page. Next slide. So as I mentioned, acetylene is very flammable. So acetylene has a very low initial, require a very low initial energy to start a fire or to start burning. You can see in the stream, right? A match, right? A match could be 1 point. A lighter spark, even your mobile phone, the infrared will able to ignite acetylene enriched environments. Non-explosions proof type of electrical appliances. So imagine for acetylene, you will consider as a flammable gas. The storage, the environment that is being used, we have to be very sure that the electrical rating of the area had to be explosion proof or classified as a class 2 zone requirement. Even camera flashlight can start the oxygen acetylene fire. You can see even for static energy that created by frictions also can start an acetylene fire or even explosion. So for this page, we have to very aware that try to remove any heat source from acetylene's storage area or where acetylene is, there will be chance for acetylene to leak out. Right, next slide. So acetylene flammable risk here, there's a few points. Majority you can see that fire hazard is one of the highest risk over here due to the flammability of acetylene. And also fire hazard when acetylene is being used for cutting, so there is a hot film. Just remember when acetylene is being used, the temperature that from the flame itself is very high. It can go to 1,400 degrees Celsius. So that the hot flame generated during the cutting, you were able to have a higher fire hazard, right? And also heat conducted by the spark, by cutting or by heat treatment with acetylene flame is also a very high fire hazard. Ignition result by flashback or the hose explosion or rupture. For acetylene oxygen setup, flashback arrestor is one of the critical requirements for this subject to prevent any flashback from the applications. Most of the time during welding or there's a spark, eye injury is one of the highest injury sustained by general public. Burn caused by high level of heat produced by the process. Acetylene is being used for heat treatment, and the temperature can be very high. Also, this is the high heat from this process. Burn by metal slat ejected from the heating process or the cutting process. Burned by the hot so-called the cutting torch nozzle. Gaseous flame that is being generated by the cutting and the consumer. The gaseous flame sometimes could be poisonous. Toxic substance can be generated during the burning or the cutting of the base material or consumable. So for this point, sometimes you may able to have a problem or risk incident that involved with toxic gas generation. Increased combustion to oxygen's enriched environment. I've been repeated a few times. So oxygens it do not burn, but it support combustions, especially with acetylene around. This combustion temperature, you can imagine it could be very high as well. Risk of oxygen's deficiency in confined space. Just imagine when you do cutting, right? Cutting, oxygen is being consumed by the environment from the environment air. With that consuming, that means they will drop the oxygen's level in a confined space. So with this risk in place, prolonged burning of cutting film in a confined space, the area will have a reduced oxygen level to the point that it will create asphyxiation risk in the area. Noise generated by some of the acetylene process, like heat treatment, cutting. So this is quite common. So end of the point here is that use personal protection equipment, ensure good ventilation, and be prepared to extinguish fire. So when you have acetylene application in place. Next slide. Right, so I will share three of the past accidents with that involve acetylene cylinder. For case one over here, this incident happened in the US. So it started off right now. There is three DA cylinder, dissolved acetylene cylinder, were kept inside a steel cubicle. a steel cubicle located in the middle of a railway workstation. So in the US, there's a lot of these railway workshop. So they are doing maintenance. So they kept three acetylene cylinder inside a steel cubicle. The customer employee noticed that there is smoke and fire inside the cubicle, so-called the steel cubicle, and withdraw, so-called they move this cubicle to a safe distance, right? And the fire continued to happen about 20 minutes, right? So at one point, some of the employee approached the cubicle. So there are few employee or worker that grow near to the steel cubicle, and one of the person kind of knock one of the acetylene cylinder over onto the ground, hoping that he will try to close the so-called put up the fire. But the moment that he kicked and this cylinder dropped onto the ground, it exploded and killed him instantly. So, and there is also surrounding, there are others employee, five of the men suffer from burn injury, and 2 of them later died in the hospital. Next slide, please. So you can see from this picture that this is the steel cubicle, and the after incidents, the acetylene cylinder, there is a very big burn hole at the base of the acetylene cylinder when it's created explosion, right? So next slide. So the lesson learned here from case 1, right? Hot acetylene cylinder can instantaneously explode. Do not approach or move or knock them. This is especially very important to know when there is acetylene cylinder subject to fire to heat, or whether it did not actually burn on itself and subject to a very high heat. Please do not approach them or go near them, or even try to knock them over. So acetylene cylinder, it will actually explode under this type of high heat conditions. So people who handle acetylene cylinder must be very or fully informed of understand hot cylinder procedure. So in these incidents, obviously the 5 worker is not aware to, and also not been told not to go near to a heated acetylene cylinder, or also try not to move them. Let them be, if possible, use water to cool them down, and do not touch them, right? So this is the lesson learned from case 1. Next slide. So here we have a case 2. Case 2, this was actually happened in Europe, right? In Europe, it's involved is transporting of acetylene cylinder in an enclosed pickup. So-called, we call it a vehicle, a van, a pickup enclosure pickup van. So a pipe fitter, right? So we have a work van left a dissolved a DA cylinder on the back seat of his double cab pickup over the weekend, right? So he put a cylinder at the back of his pickup truck in the enclosure over the weekend. So acetylene valve was not probably it's not fully closed, and there is a leak occur. So there is a acetylene accumulation inside the van. So on the Monday morning, as soon as the fitter opened the door, a huge explosion took place. So the initial could be from either from the following possibility. So it's an internal light circuitry inside the vehicle, inside the van, to automatic door remote control. He may have pressed the remote control on the van remote control that to open up the door. He also, there is a mobile phone that was left on the front of the seat. And also at the same time, this fitter, he is a smoker. He could have a secret light out, but when he open up the van door, and then this created an explosion. This is some of the possibility. Right. Next slide. So you can see that there's a damage of the double cab pickup. It's very big explosion, very nasty. Next slide, please. So the consequences, the fitter have damage to his eardrum and injury to his face. Definitely, the cab was been badly damaged. The lucky part that this fitter is only seriously injured, but not life-threatening. So the lesson learned here is that never store acetylene cylinder in an enclosed vehicle or area. So there is a possibility if there is leak, you create a very explosive environment. Just to recall, acetylene require very low energy to start a fire or an explosion. Right, so this is next slide. Case 3 is also involved in transporting of a DA cylinder in the horizontal positions, and this happened in Asia. This incident happened in Asia. So a DA cylinder was lie down on a pickup truck or cab on the way to a work site. So roughly about 10 minutes of the journey, the driver of the cab noticed that smoke arising from the back when he looked at the back rear mirror, right? Rear view mirror, there's smoke coming out. So this driver react fast enough. He drove the pickup truck to an open air parking area, and he got out of the vehicle. Immediately, fire broke out at the back of the cab. The vehicle was badly damaged. So here is the cause of ignition could be the leakage of the acetone from a DA cylinder valve when it was actually being lined horizontally. When this acetone, actually flammable acetone, leak out, and he got into a hot, could be hot contact with the truck surface, and he caught fire. Now next page, please. Next slide. Yeah, you can see from the photograph, the cap is burning, and after that, the damage of you can see that the acetylene cylinder actually is still in the cap. It's been lying down. So there's no explosion due to this cylinder. So basically, we can rule out that it's not an explosion created, rather than it's a leakage of a flammable liquid that creates the fire. So lesson learned: never transport a DA cylinder horizontally or lying down. Right. So this is case 3. Next slide. So here I will want to kind of identify the major hazard at workplace, right? For the involved oxygen acetylene cutting setup. So make sure that the major hazard is the poor ventilation, leakage of cylinder valve and hoses, faulty equipment. Always remember to prevent flammable vapor. Next slide. So here is a typical setup of a oxyacetylene cylinder equipment. Please take note of those red box. The red box are the recommended necessary safeguard from some of the country regulations, right? Like in the Europe and also in Singapore. So typically for this type of a setup, we would need to have a regulator, right? The regulator, to bring down the cylinder pressure to the application pressure. And also for acetylene cylinder, the regulator would have a maximum discharge pressure of 1.5 bar only. So anything higher than 1.5 bar, acetylene is very reactive and versatile. And also we can see that flashback arrestor are a kind of a requirement in some of the country regulation. And normally flashback arrestor will be installed at the downstream of the regulator. And then there is also a non-return valve at the end of the cutting torch. These are the few kind of standard safeguard requirement for this acetylene cylinder setup. Right, and next slide. Next slide, please. Yeah, so here is some of the safety awareness. Acetylene cylinder should use by in vertical position. Don't put down. Don't use acetylene cylinder in horizontal positions. Large cylinder to be secured with strip or chain. Right. Do not crack open cylinder valve to blow out dust from the gas outlet. So it's very common. We can see that there are some dirt on the cylinder valve outlet. You just crack open and blow out. Please do not do that with acetylene. If you can see there is a dirt on the cylinder valve outlet, you can actually use a clean cloth to wipe off. Do not use the gas itself to blow out. Select proper gas nozzle for the right flow rate for cutting requirement. Before light up a torch, purge each of the gas holes separately for a few seconds. This is to get rid of a high oxygen content. Never bring a light torch near to a gas cylinder. So sometimes when there is a leaking on the cylinder valve, if you bring a light torch near to it, actually you create a fire or even an explosion on the cylinder itself. Do not use acetylene at pressure higher than 1.5 bar. It's become very unstable. All right, so this is the thing. Next slide. So here I'm going to share some acetylene cylinder storage best practice. So never store acetylene cylinder in an occupied building, under a ventilated room, underground room, or public area where it's very easy accessible by general public. Store away from heat and emission sources, flammable and corrosive material. Ensure the area is designated as no smoking, and also remember for flammable area, the electrical appliances have to be explosion proof. Next slide. Here you can see one of the incident sharing when acetylene cylinder are stored inside an enclosed cabin. Acetylene vapor leaked out from the valve outlet or fusible plug. The moment when this steel cabinet open, there will be a risk that there is an explosion or fire created would happen. All right. So the steel cabinet, when you open the door, there could be frictions from the hinge or from the side. A small amount of energy can actually create an explosion when acetylene leak inside an enclosed compartment. Next slide. So here is some of the best practice for safe transportation of acetylene cylinder. So here is that make sure that acetylene are transport in adequately ventilation is important. Use an open top vehicles or vehicle that designated for transport dangerous goods for acetylene transport. Always ensure the gas cylinder are fixed and secure for transportation on the vertical position, and also separate from the driver compartment. Never park a vehicle with acetylene cylinder in an enclosed or covered area or public garage. Please do not park inside there. When at the destinations, we reach the destination, immediately remove any cylinder from the vehicle and do not store cylinder inside any of the vehicle. Always close the outlet valve of the individual cylinder if it's in the bundle, or just to ensure that there is no leakage from the bundle itself. So on the side, we can see that when a DS cylinder exploded while in transit in an enclosed van. Right, so do some sharing. Next slide. So there is a reference material from AIGA. You are interested, you can go to AIGA website over here. Can download for further reference. It's free of charge, by the way. With that, I think I have finished my presentation today. Thank you.
Thank you, Alvin, for your presentation on the acetylene cylinder safety and incident. Ladies and gentlemen, we will now move on to the last presentation for this virtual workshop, where we will, we have Encik Ivani bin Ismail from the Industrial Safety Division, sharing with us on the DOSH guidelines for industrial gas cylinder 2021. So briefly about Encik Ivani, he has a Bachelor of Science in Mechanical Engineering and also Master of Science in Occupational Health and Safety. He joined DOSH since 2003 and currently with the Industrial Safety Division since February 2020 as the head of Unfired Pressure Vessel Unit. With that, pass the floor to Encik Ivani.
Thank you, Ms. Petwan. Assalamualaikum and a very good morning to everyone. Apa khabar semua? I do really hope all of us are in good health during this pandemic, inshallah. This COVID-19 really causes hardship in almost every aspect of our lives. I've been informed this workshop was initially planned for physical, but due to the current situations, we have to do it online. Anyhow, life must goes on. We'll do whatever possible. Okay, first and foremost, let me thank you all for joining us today. I'm very delighted to be part of the workshop and particularly thank to the main committee. We couldn't have pulled off this workshop without the hard work and dedications from the main committee, FMM Myanmar, supported by AIGA, Asia Industrial Gases Associations, and last but not least, of course, from our department itself, DOSH. Okay, taking this opportunity also, I would like to thank to the other three speakers for a very fruitful session just now. I actually feel so very short of words to praise all of you guys for the efforts that you actually make in sharing your very knowledge with us today. And perhaps with all the technical information shared, it will be beneficial for us to some extent in carrying out our routine tasks. So tons of appreciation and applause to all of us for making this event happen. Okay, even most of the audiences are from DOSH, I guess. I do believe some of the officers, we didn't even have a chance to greet each other, especially for those who are stationed at the state office. Hopefully, with the brief introductions of myself just now, you know where to find me if you need any help on the design approval for the unfired pressure vessels. Okay, during the next 30 minutes, I will be updating you guys on the guidelines for industrial gas cylinder. We focus on design, construction, handling, inspection, and testing. Okay, sorry. Okay, there are various types of industrial gas cylinders in Malaysia nowadays. As of now, there is no proper control either by the authorities or agencies are looking at it. So for that reason, DOSH is taking initiative to develop this guideline. Okay, a little bit about chronology of the development of this guideline. It was actually started out since end of 2016. By that time, I was not with the committee yet until February last year. So there's only 7 of us who prepared the guideline, and the chairman already retired March this year, actually, before this guideline came out. And for your information, this printed guideline has just been published and officially presented during our department policy review meeting on August 17 last month, very recent, less than a month ago. So it is not yet officially launched by our DG, and our committee member are planning to do it very soon, most probably somewhere in October this year. Okay. Looking at the content here, allow me to give an overview of the whole guideline before we look at them in details. Okay, we have decided to break down this guideline into 8 main topics, which is we reckon that it will cover from the legal part in chapter 2, and the cradle to grave approach for the cylinder itself, as we thought the other 6 topics from design stage to dispose of cylinder. I mean, from chapter 3 to chapter 8, from section 3 to section 8. We do expect with the topic selected, the industry can at least use this guideline as a reference. And of course, this guideline is dynamic and will be continually improved from time to time. Next slide, please. I do believe all of us know, I mean, gas cylinders are used in a variety of industry like water treatment, food processing, laboratories, or even in workshop. But anyhow, they are most commonly used in medical and manufacturing industries. If we talk about medical industries, what manifests me the most now is the use of oxygen tank for COVID-19 patients. Yeah, we use a lot of oxygen tank during this pandemic, actually. Okay, while in manufacturing, gas cylinders are normally used for storing fuel for heating system or for vehicle also. And some of them are used to store the source of energy for power tools or assembly line as well. And like any other guidelines, we also do include some of the interpretations that is meant for this guideline, unless otherwise the context require a different meaning. Okay, actually there are a few other terms that I didn't put on the slide, like inspecting authority, which is the same as defined in our Factory and Machinery Act. Okay, what is actually a cylinder? Actually, cylinder is either a refillable or non-refillable compressed gas container that is commonly used for storing or transporting compressed gas. As you can see on the screen, there are few different states of compressed gas can exist. It can be in the form of liquefied gas or non-liquefied gas. And acetylene is one of the examples for dissolved gas, as explained by Mr. Alvin before. It is known that acetylene is chemically unstable and flammable at atmospheric pressure. Therefore, it needs to be dissolved in acetone or DMM, dimethyl formamide, in order for it to become stable. Okay, another form of compressed gas is cryogenic liquid. I guess everybody knows that these refrigerated liquefied gas are kept at a very, very low temperature, and it can cause frostbite or blisters if our skin is exposed to its gases. Okay, in the introduction as well, we have listed out the hazardous properties of the compressed gas, just such as oxidizing, cryogenic, corrosive, and so on, as you can see on the screen. Just bear in mind that the compressed gas can have one or more hazardous property, like it can be flammable and corrosive at the same time. And for the asphyxiant type of gas, it is capable of displacing oxygen in the air and may lead to suffocation to anyone who is exposed to it. Okay, let's move to the next slide. As I pointed out earlier, the main reason why DOSH decided to develop this guideline is to provide advice and guidance to any person or organization that is involved with design, construction, handling, inspection, and testing of all compressed gas cylinders. And we are extremely hope that by having this guideline, all the relevant players out there will comply with the minimum requirements that we have set out in this guideline, hopefully. Even though it's just a guideline, we firmly hope that it will reduce the risk and help to prevent accidental damage to injury to people or properties or in environment. Okay, if you look at the scope there, this guideline is intended to cover for gas cylinder ranging from 0.5 liter to 150 liters water capacity. 0.5 liter water capacity is just the size of mineral water, and for 150 liter, if you can imagine, it is just like the size of an air compressor tank in a workshop, or the size of a wheel fire extinguisher also. And for your information, right now we are in the process of developing LPG cylinders guideline. I believe committee members are in a final stage for legal advisor approval. Actually, I used to be part of the team for a few years before I joined this new division last year. Okay, what I'd like to draw your attention is this is the reason why LPG cylinders are excluded from this guideline. You can see at the very bottom right there, we put LPG cylinder, it is excluded. And yeah, we are preparing another guideline which is specifically for this LPG cylinder. Okay, other than that, this cylinder also is not applicable to cylinders that form part of a vehicle like NGV cylinders for cab or taxi. Aerosol containers, gas cartridges, fire extinguisher, and non-refillable cylinders are excluded as well. Okay, for specific gas applications such as welding, diving, inerting, etc., additional special requirement apply, and it is not covered in this guideline. Okay, let's take a look at the next slide. Okay, from a legal point of view, gas cylinder is clearly defined in Factory and Machinery Act, but not in OSHA 1994. Anyway, cylinder has been defined as machinery in Factory and Machinery Act, whereby in OSHA, machinery is part of plant definition. So in addition, gas also has been interpreted as a substance under Section 3 of the OSHA. Actually, this is just to show the enabler for us to develop the guidelines. Next slide, please. Okay, apart from the definitions of gas cylinders and substance, general duties of employers, general duties of employees, manufacturers, designers, and so on, as listed on the screen, are among the sections of the Act that closely related to the use of gas cylinder. Okay, their duties is to ensure the use of plant or substance are safe at all times without risk to anyone. Okay, let's jump to chapter 3, please. Okay, we as a consumer will definitely concern on the safety of the cylinder while we are using it. Cylinder and their closure must be designed, manufactured, tested, and equipped in such a way to withstand all conditions, which is including fatigue, either during operations or during transportations. And this cylinder also should be designed and manufactured in accordance with the current cylinder standards. Okay? Among the most common national standard is the one that has been presented by Mr. Anthony this morning, which is MS 2542 2013 gas cylinder package, which is excluding of LPG cylinder and firefighting. Actually, some of the information that has been explained in detail by Mr. Anthony this morning. Anyhow, I'll just continue whatever material that I've prepared. In this part also, we have outlined an additional requirement specifically for gas cylinder to contain acetylene and refrigerated liquefied gas. Yep, again, as explained by Mr. Elvin, acetylene cylinder must be filled with porous material and uniformly distributed so that it can prevent the spread of the compositions of the acetylene in the porous material. Yeah, we have heard very detailed about acetylene this morning, just now. All right, we move to the next slide. Okay, prior to construct of a cylinder, selection of material are very crucial because we cannot afford to opt a material that weakened by the dangerous good intended to be transport, or can cause dangerous effect to human or properties. We should consider its mechanical strength, corrosion resistant, and impact resistant before we choose which material that we are going to be used. Okay, as you can see on the screen, there are 4 types of material that are commonly made out of. The most important thing is that I want to stress up here is we have to make sure the cylinder and its closure shall be made from the material specified in the design and construction technical standard as explained by Mr. Anthony. Okay, next. Okay, this one is more to highlight on the proper use of supporting equipment, or we call it service equipment, which is purposely designed to prevent any damage to the cylinder and might release gases or liquid during the normal conditions or also during transportation. Okay, gas cylinders and skid are just 2 examples of many others that we have out there. So yeah, next slide, please. Okay, as far as we are all aware, Dodge is not giving out any design approval for this type of cylinders. The conclusion that we can draw from this figure is the role of the inspecting authority is very crucial, as they need to inspect, they need to test, and lastly approve the cylinder. As required by the codes or standards, the conformity of cylinder shall be assessed during the time of construction, during the manufacturing. Okay, let's see what do we have on the next slide, please. Okay, part 4, gas cylinder valve and regulators. To illustrate this, let's have a closer look at, again, the main components of compressed gas cylinder and regulator assembly. A valve is usually attached to, to open end of the cylinder and normally located at the top of the cylinder, or sometimes at the shoulder of the cylinder, so that it will ensure the gas, to be contained within the cylinder and not released to the air. So the gas cylinder valve is a primary safety mechanism on the gas cylinder. And of course, it shall not be tempered at any time. Looking at the function of the valve guard, it is commonly used to protect the valve assembly from damaging when the gas is not in use. Okay, let me take a look at the function of the valve on the next slide, please. Okay, in terms of safety, valve is as important as cylinder, and because of that, valve should not be designed, constructed, and tested according to. It should be tested according to any national standard or international standard like Malaysian standard or ISO. And another thing is that the manufacturer should consider before construct any valve by choosing a compatible material. The reason behind this is because valve is going to be used in various gases, different properties of gases. So typically, each valve can last for at least 10 years of service, depending on the usage. Okay, there are a few examples of valve function that we can come up with. Definitely be more than that, actually. Okay, among them is to provide closure to contain the contents within the cylinder without leaking. Other than that is to provide inlet and outlet port, either for filling purposes or to release gas. And another function is to accommodate safety devices like a non-return valve, pressure relief valve, and residual pressure valve. And of course, it can also provide as mounting for external components like regulators or pipeline. Okay, let's move to the next slide. Okay, valve protection. Okay, this one has been touched by Mr. Anthony. Okay, Okay, this is just want to show the ways of protecting the valve from mechanical impact, especially for larger cylinders. As you can see, the valve guard stand higher than the valve hand wheel, and you don't have to remove it if you want, if you want access to the valve. The valve shroud is commonly used for LPG cylinder, the same that we have at our home. And for valve protection cap, it is normally used for transporting or during storage. It covers, is securely fixed over the valve, and you need to remove it if you want access to the valve. Okay, next slide, please. Regulators. Okay, the regulator is the most important safety device also to be fitted to a gas cylinder before we use it. This is because its function is to bring down the high pressure of the cylinders, to a workable pressure. Regulator comes as a single stage for short-term applications, and for two stages for long-term applications. And regulators also constructed from different materials, mainly from brass or stainless steel. And regulators are designed to be fitted directly to the cylinder valve, so that no other fittings or lubricants are needed to connect a regulator to a gas cylinder valve. And regulators for flammable gas are left hand-threaded and have a notch cut out of face on the securing nut. This is just to differentiate them between the, with the non-flammable gas regulators. Okay, always. Yep. Okay. You need to always connect a gas cylinder to the item being charged by a regulator and any appropriate pressure system components. To note that some valves are designed complete with regulator, such as a VIPR valve with integrated pressure regulator, which includes pressure and sometimes for flow regulations, making them suitable for connection directly to device. Okay, we'll see on the next slide, pressure relief devices. Okay, most of the cylinders or manifolded cylinder pack are fitted with a relief valve. In a situation where excess pressure is encountered, a relief device is designed to discharge cylinder content either completely or just excessive pressure, maybe half, maybe 3/4. Okay, discharge of a pressure relief device will normally produce a high-pitched noise and a jet of gas at high speed. As you can see on the screen, there are 3 types of commonly used pressure relief device. The first one is burst disc, fusible plug, and the last one is pressure relief device. Pressure relief valve. Next, please, Mr. Okay. Every cylinder and their contents must be clearly identified for the benefits of all users, as well as feelers, periodic tester, and transporters. For emergency responders, they need to quickly react in the case of emergency involving the use of a gas cylinder. So with the proper marking and labeling, it will facilitate anyone that comes in contact with the cylinder or the gas that they are dealing with. As you can see on the table, we have outlined a guide to manufacturers on the form marking based on the items. Like, for example, the name of the manufacturer should be permanently marked on or stamped on the cylinder. So, okay, just skip to the next slide, please. Yep. Okay, different countries have different color coding system to classify different gases and types of cylinders. So in order to provide the information of the cylinders, this identification marking are used to indicate important data about the capability, ownership, or inspection history of the cylinder. Usually for the stamp marking of compressed gas cylinder, we are going to refer to ISO 13769 because this specifically for gas cylinder stamp marking. As you can see, at the top row of marking, it written a manufacturing mark like the country of manufacture and the serial number. And in the for the middle row, it contains normally contains operational mark like minimum wall thickness, stair weight, and so on. And at the very bottom row, it will show certification mark from UN and the country of approval. Okay, in these sections as well, we emphasize some of the information about marking issue that cannot be ignored. One of them is we can never rely on the color of the cylinder for gases chemical identification because the color coding is not reliable and may differs between suppliers. So that is the reason why. Okay, let's move on to the next slide, please. Okay, it is the filler's responsibility to ensure that all cylinders that they fill are correctly labeled as to the cylinder content. When a gas cylinder contains a hazardous substance, it must be identified and labeled to the classifications of the hazardous substance as per class regulations 2013, our in offshore. Okay, the label should be should have also the general precaution that needs to be taken in order to prevent the adverse effect. And our responsibility is to read the label and read the STS first before we use, so that we know what type of chemical that we are dealing with. Okay, next slide. Okay, these are the two standards that commonly refers by the industry when it comes to storage and handling of gas cylinders. The content of cylinders store the energy that has gone into compressing them, and if the cylinder is weakened, this mechanical energy may be released violently. And some gases also store a considerable amount of chemical energy, and it may react chemically with the environment and increase the violence of the release. Therefore, proper handling of gas cylinder is very critical here. Okay, move on to the next slide. Handling and storage for transportation. Okay, cylinders should be stored and handled and used in upright position whenever possible, unless they have been specifically designed for horizontal use. When we talk about transportations of cylinders, this guideline should be read in conjunction with any rules and regulation in Malaysia that has set out the requirements for things like load segregations, documentation, placarding, and load security, since they're providing more details about this. So we just covered the very surface of handling for this guidelines. Okay, this are just a few examples on how a cylinder should be transported. And the key point here is this should be secured by any means, like the use of supporting cradles or tie-down strap. And yep, for flammable and toxic gas cylinders, they should not be stored in the same compartment as the driver or passengers. As it will endanger the driver in case of any leakage or fire. Because we have seen the incident just now by Mr. Albit. Okay, and then the last one is no part of the cylinder or valve should project beyond the dimensions of the vehicle during transportation, because this is to prevent the valve from colliding with any other object during transportation. Okay, let's move to the next slide, please. Okay, we're still in handling and storage. Okay, what are the things that you need to consider? Things that you need to consider before you store your cylinders. As you can see on the screen, we strongly believe that these 9 points should not be left out during selection of locations for cylinder storage. For example, in case of flammable gases or oxidizing gases, it must be separated from any potential source of ignition, and portable fire extinguisher are in place at all times. In the case of flammable gas, cylinders should be stored at fire-resistant construction, as it will contain the fire within the area and not spreading out to the other areas hopefully. Okay, if the area is poorly ventilated, the potential of the toxic gas, can accumulate very high and may cause explosion or death to those who are exposed to the gas. Taking all of this point into account, we anticipate that the storage area for this cylinder is in good hand. Okay, let's move to the second last chapter, filling cylinders. Okay, this topic is particularly focused on the responsible person to do the filling and what to check before and after or during the filling. And in this section also, we have set the minimum requirements for facilities or filling stations that need to equip before they start to operate. Okay, cylinders should be filled by a trained person only, and we call them a filler. To become a filler, a person should at least know and familiar with different types of gas, compressed gas. Like he knows how to differentiate between low pressure liquefied gas and high pressure liquefied gas, and what is cryogenic gas, something like that. And he also should know what are the factors that can trigger failure of a cylinder. And other than that, he must be able to tell the potential adverse effect caused by compressed gas. And he also can tell what are the requirements of relevant standard or codes covering the visual inspection and safe charging of a cylinder. And as a filler also, he is responsible to record the movement of each cylinder and the date of the cylinder to be re-qualified. And he also needs to ensure the cylinders with a valid re-qualification date only can be refilled. That is the responsibility of a cylinder, a filler. Okay, let's move to the next slide, please. Filling, okay, pre-filling checks. These are the things that a filler needs to check before he refills any cylinder. First thing is the cylinder is marked according to standard and still within re-qualification test period. Good external physical conditions, cylinder marking and labeling are readable and correct. Valve is in good condition. Prior to filling, the filler needs to inspect and assure the cylinder is authorized for the gas. Okay, let's see what else he needs to do during the fill up gases on the next slide, please. Sorry. Okay, once the filling starts, the filler should ensure that the cylinder is not leaking via its neck thread or valve cylinder, and he should never exceed the manufacturer's recommendation rate of filling, and he is not allowed to leave the filling points at all time while the cylinders is being filled. He should be there all the time during the filling. All right, let's see what the filler needs to check during post-filling check. On the next slide, please. Okay. After filling, a filler needs to ensure shut or valve is closed, and remain closed before transport. Again, he needs to double check on the level as mentioned earlier in section 5.2 of this guideline to make sure it is correct. He then need to verify the name or other suitable identifications of the filling station. The crucial part is to check for any leakage. It's either by using leak detection fluid, LDF, or immersing the cylinders and valve in a water bath, or maybe use electronic leak detector. And no less important is to ensure the final fill pressure or fill weight is not exceeding the setting limit. And before sending out the cylinder to the customer, the consignor responsibility is to verify that the closure and equipment are not leaking before he start delivering. Okay, let's see what do we have on the next slide. Filling cylinders. Okay, decant filling. As far as I'm concerned, decanting is one of the most complicated issues to solve for the LPG cylinder, but I'm not really sure about other cylinders. Okay, for this case, decant filling by weight control method is permitted for cylinders with water capacity less than 5 liters only, and the pressure must only come from the supply cylinder or tank to transfer the gas, meaning that a pump is not allowed here. Okay, go to the next slide, please. Okay, this is just to explain on what is likely to happen once you overfill a cylinder. Okay, when the expansion of the liquid phase takes place as the temperature increases, it may cause the cylinder to become liquid full. If the temperature keeps continue to rise, the pressure in the cylinder will also increase, and will be likely to force up the liquid or gases through the pressure relief valve, risking the valve malfunction, or other appliances also is not functioning. If the pressure relief valve fails to operate, the cylinder may burst, or even with a small rise of temperature. So this the consequence of overfilling. Okay, let's go to the next slide, please. Okay, cylinders shall not be offered or for filling or transport when when it is leaking, and when let's see. Okay, when it is damaged to such an extent that the integrity of the cylinder or its service requirement, service equipment may be affected, and when the cylinder is beyond its qualification time, also we are not allowed to refill or filling, and then cylinder may be offered for filling and transport when the cylinder and its service equipment has been examined and found to be in good working order, and also the required certification, retest, and filling markings are legible. Next slide, please. Sorry. Okay, requirements for filling stations. The owner or occupier of the station who is responsible for day-to-day operations must ensure the requirements of the relevant act and regulations that he needs to comply with at all times. He not only needs to hire a high standard of competent filler, but also need to keep all the equipment and at his filling station well maintained. This is just the minimum requirement that an occupier needs to consider before operate filling stations. Okay, first thing is the filler must be trained and capable of handling gas traffic and know the gas that he is handling with. Okay, in order to keep the filler safe at all times, it is the occupier's responsibility to provide a proper equipment or PPE during the filling. And the last one is he needs to separate between cylinder filling area and the storage area by certain distance, and of course keep them clean and orderly at all time. Okay, next slide, please. Okay, the equipment. Okay, just now we emphasize more on occupier's responsibility. So now we come up to the next point where we're going to look at the items that a filling station should be equipped and maintained throughout the operations. As you can see, there are 13 items. The first one is cylinder filling instruction, so that the filler won't miss or skip any steps during the filling. And then the second one is using the correct pressure rating filling hoses, and it is suitable for the gas being filled. The next one is all required cylinder fillings connection are properly in place. Make sure no missing part. This is to avoid any flaw during transmission. And another thing is soapy water solution or water bath for leaking check. And always ensure using a valid weighing scale. Portable fire extinguisher is provided at all times, and to provide relevant hand tools for filling connections. Filling station identification label for easy tracing, just in case anything's happened during transportations or in use. Next is identification label for cylinder contents. Suitable PPE like leather gloves or eye protection. Last but not least is the first aid kit and warning sign on site at all times. Okay, let's see on the next slide. Selection of location and infrastructure are very crucial also before making decision in developing a station. There are, the area where the filling stations to take place shall consider all these points on the screen. The first one is it should be open area and having a good ventilation system. It is constructed from non-flammable materials, having a firefighting equipment or facilities on site, have adequate lighting, ergonomically designed and laid out, and the list goes on. Okay, not to forget a comprehensive risk assessment as such should take into account all possible control are identified in order to reduce the risk. Okay, next slide. Very last. Okay, let's now take a look at our very last sections of the guideline: inspection, testing, requalification, and disposal. Every new cylinder is subjected to testing and inspection during and after manufacture in accordance with the applicable standards. Okay, to name a few standards that relate to periodic inspection, testing, and requalifications of compressed gas is FS1720, welded carbon steel gas cylinders, periodic inspection and testing, AIGA IGA 090, reference guide to requalifications of gas cylinder. Okay, almost in every standard stated a cylinder is due for periodic inspection and test on its first receipt by a filler following the expiry of the interval. Okay, requalification method will be based on a variety of factors, including cylinder specifications, gas service, and purity level. Authorized requalification cycle, location, turnaround time, and price also determine the method of RQ requalification. And cylinder must be requalified periodically to remain in service, of course, and it should not be used or refilled if it's beyond requalification time. And if cylinders are no longer fit for service, it must be disposed of in a safe manner, of course. Okay, let's see on the next slide. Okay, cylinder disposal. Okay, these are the normally the four possible reasons why you need to dispose of your cylinders, other than because the life of cylinder is over. Okay, the first two is because of the external and internal condition fail during inspection at time of failing. It may be because of design is outdated as well and no longer suitable to use. Yeah, that is the reason why cylinder ready to dispose. Okay, next slide, please. disposing of a gas cylinder correctly is extremely important, particularly in today's climate environmental awareness. If we dispose of cylinders as a normal waste, for sure it will create problem like safety hazard for the landfill and for the recycling workers as well. You know, compacting or crushing a disposed gas cylinder may result in fire or explosion. And of course, a correct disposal method will definitely improve public relations and help you to stay in compliance with local authorities and requirements. Okay, these are the least steps to dispose of cylinders. Okay, once you done a proper PPE, you can release the residual gas content in a safe manner and then remove the valve, make sure there is no gas left in the cylinder, and then damage the thread neck completely and make sure it cannot be used again. And finally, cut and destroy the cylinder. Yep, there is a special requirement as mentioned before for acetylene cylinder. Okay, you can refer to IGA 036 16 revisions of IGA 036. I mean, Asia Industrial Gases Association management of waste acetylene cylinder or other relevant international standards. Okay. Well, this brings me to the end of my presentations. Thank you so much for your attention. I'll pass back to to Ms. Chan. Sorry, Ms. Chan, give back to you.
Thank you, Encik Wani, for your presentation and sharing us with the new DOSH guidelines for industrial gases cylinder. Ladies and gentlemen, we will then now move on to the Q&A session. Okay, the Q&A session will be facilitated by Mr. Chan, our chairman of FMM MIGMA Technical Committee. And as mentioned earlier, questions can be submitted through the Q&A function of this webinar platform. So with that, I pass this to Mr. Chan.
Okay, thank you, Pick One. So I think we are running about a little bit of time. So let's start for the Q&A session today. As you can see at the Q&A sessions, I think first question referring to Anthony. This is a question from Wilson Dosh Sarawak, mentions that he has been involved in the cylinder explosion accidents investigations, and then they found out the cylinder was contaminated with other substances inside. Is there any advice for end user to prevent this? And then he also mentioned about, is there any acceptance criteria when the end user receive a cylinder? What kind of criteria they should refer to? Anthony?
Okay, for end users, firstly, they should, after use, the condition is such that they should always close the cylinder valve. Okay, and when a good practice is whenever the regulator shows less than 5 bar, a usable cylinder, when actually it drops down to a level of less than 5 bar, the tolerance is between 3 to 5 bar. The usability of the gas inside the cylinder is no longer viable. In that sense, they should actually close the valve and then remove the regulator and return it to the manufacturer. A lot of times, the users want to draw what we call every single drop out from this cylinder. So they will always try their best to zero out the cylinder. Okay, when that happens, and when they leave the valve open, the cylinder is subjected to, they will put it inside the yard, like in the open area, and temperature subject will move the cylinder to a higher temperature and then to a lower temperature. This causes what we call a sucking effect. Okay, this sucking effect draws contamination from the external into the cylinder itself. So that's why the practice of closing it after use and also ensuring that there is a low positive pressure between 3 to 5 bar when they return to the manufacturer or the supplier is needed. Another standard that you can reference to is MS ISO 11625, gas cylinder safe handling. Okay.
Okay, thank you, Anthony. So I think maybe like what Anthony just now have been shared as well, the minimum pressure retaining valve also can prevent any contaminations by the end user. Okay, there's another question from Wilson to Jaslyn talking about can we use the infrared thermography to check on the cold box for any leakages? And if yes, what is the frequency or how often they should do the check? Maybe for a speaker, when you answer the question, you also can switch on your video. Yeah, thank you.
Okay. Switching on the view. Yep. Okay. So for thermography scanner, it can be performed annually, but please note that this kind of test is actually allows you to detect leak that is large leak. If it's a small leak, your temperature wouldn't really goes down. So it can't really be detected by this thermography. You will still have to have a periodic, maybe a weekly check on your or monthly check on your O2 sample port. Yeah, so your O2 content from all the sample port along the cold box and also all your temperature sensor and pressure sensor. So I have seen some guidelines or recommendations from those ASU manufacturer. They do recommend annual, but this is also depends on individual sites also.
Okay, I hope this answer the question from Mr. Wilson. There's one question from guest GPT from Jeff Jeruf, asking the question to Encik Iwani. Who is the authorized inspection agency for cylinder inspection? I think they are referring to the cylinder requalification process or hydrostatic test.
Okay, sorry. All right. Inspecting authority here is referring to the one that we have listed in our first schedule, Factory and Machinery Act, Steam Boiler and Fire Preservation Regulations, 1970. We have like 43 IA inspecting authority that we have listed up there. For example, is like Lloyd's, TUV, BV, Bureau Veritas. Yeah, the few that I can. Oh, sorry. Yeah, that's some of the example that I can give, like Lloyd's just now. TUV, Bureau Veritas, and also what else? SGS. Is in the list of for schedule actually.
Okay. Jeffrey, any further question from your side? Or you're okay with this? Okay, then maybe we can go to Jasmine. There's a question from Dr. Ramuna talking about, can you briefly explain on the type of the maintenance that should be conducted for cold box? What type of inspections and when and the frequency, perhaps?
All right. Okay. So maybe I share my screen because in my slide just now we do highlight IGAR, the list from IGAR. Can you see my screen? Yep. So we can see that the list from IGAR. Yep, so this is our IGAR Safety Bulletin 22/20. So they do have a list of what item you can usually check on inspected. So usually for the safety of the cold box management, maintenance, we don't really have much tests. We are more on checking the cold box pressure, especially the N2 purging. Yeah, so usually we have you can have a weekly inspections to verify N2 purging system. For example, the flow. How much is the flow, what's the pressure, and also to detect, do you have any eye spots on the cold box casing? Do you see any eye spots? So visual inspection is also very important. Then you can perform quarterly inspection to detect cracks, rust, damage on valve booth. So from the first incident that we mentioned just now, because of cracks like this, they need to maintain this item properly. The moisture actually managed to goes in. So do not forget to check the cold box roof. Then you can perform a yearly polite inspection and then ensure the safety blow-off devices. This one you can have periodic maintenance, like those reliability to confirm the reliability of all your safety blow-off devices, all your temperature sensor, your pressure sensor, and then your temperature gauge, pressure gauge also. Then also you can have make sure that the weighted disc, especially the weighted disc on top of the cold box, can move freely, not obstructed by ice. And the devices releases gas from an internal liquid, avoiding any overpressure of the cold box casing. Then the painting and primer during a plant turnaround is very important. When rusted area are warm and free of ice and condensate. And still you need to consult expert like ASU cold box expert whenever you suspect any leak on how to maintain, how to mitigate, and how to do the risk assessment on how to repair it also. Yep. So
okay, thank you, Jaslyn. So I think the key, the doctor can refer back to the IGA Safety Bulletin 20/2020 for the cold box inspection checklist. Then you have a better understanding. Okay, then maybe we quickly take another 1 or 2 questions before we closing for today's. This is a question from Encik Nizam to Anthony. Is there any requalifications requirement for gas cylinder? If yes, what is the time frame?
Okay, so for gas cylinders, the requalification is normally 5 years or 10 years. There is a specific requirement inside the standard to ensure that the internal dryness of the gas and also the cylinder internal condition before extending it for 10 years. The reference standard for this requalification requirements is MS ISO 6406 for steel cylinders, 10461 for aluminium cylinders, MS 1512 for DA cylinders.
Okay, thank you, Anthony. This is Encik Samsul Izzah from UPM. He got question to Encik Iwani. Is there any special regulations related to customized mixture, gas mixture? He gave an example like 25% methane in hydrogens, 1% helium in air, if let's say it's inert. Is there any difference of regulations? Encik Iwani, you want to answer?
Okay, as far as I'm concerned, there is, you know, I don't have any exposed to the question that I don't really, to be honest, I don't really have any idea. I mean, if there is any specific regulation, I mean, is there any specific standard that we are referring to? To be honest, I don't have any idea on that.
Okay, thank you, Ivani. But maybe just to share, from my understanding, if let's say this is a flammable mixture, then should not be any issue because it's flammable gases. But supposedly you want to have a mixture with oxygen and hydrogen, for example, then there's some special requirements or some procedure we need to follow through. You cannot simply mix with hydrogens and oxygen, for example, right? But if you're mixing for inert gases with flammable or inert gases with inert gases, I don't see any issue or concern. Or maybe technical committees, anybody else want to add on this? Okay, Anthony, you want to say something?
Yeah, the reference should be following to the if I'm not mistaken, there's a DOSH purple book or something like that, right, for gases. Then also for the connection, because everything is related to the connectivity onto the cylinder itself to ensure that we don't mix up the gas. So there is normally we will adopt a CGA, Compressed Gas Association US guidelines on the connectivity to ensure that we have the proper connections to the gas itself.
Okay, so I got another questions from Kat to talk to Anthony. To Anthony is how to implement MS 25422013 standard. Any authority body enforcing it?
I think the slide pack that was provided by the presentation provided by just now covers this already. Yeah.
So I would like to say that this is a core practice or standards for Malaysia standard. Then all the user or even the gas manufacturer or refiller need to observe. This is for our good or for people and the user safety as well. Okay, with that, I think any other questions from the floor here? This is what I can see in the Q&A now. If let's say no more questions, I think I would like to take this opportunity to close these sessions. Before I close today's workshop, I just want to quickly say a great presentation by all the speakers. Appreciate the good effort you all have put in to prepare the slide. I know it's not easy, and with the limited time frame and also the limited time as well. So thank you for the sharing today. I really appreciate that, and I hope all the participants also have the better understanding now for today's discussed topic. And if you have any further questions, you always can drop us the questions, then we will take it forwards. Okay, so as like what this morning Engineer Haji Muhammad Hatta just mentions, right? This is our first sessions for this engagement within DOSH and within the MEGMA members, so we can have a more future dialogue in order to understanding each other better. Okay, so I also would like to take this opportunity to thank MEGMA Exco, led by Mr. Eugene, for supporting this workshop, and also my MEGMA Technical Committee for organizing this workshop, and also special thanks to Peg One. She have helped a lot for organizing this workshop. And of course, not forgot, we have a lot of good support from Aiga, from Milan, from Jesslyn, from Alvin, yeah. And thank you so much. And also the DOSH speakers. I think this is a good collaboration between the industrial as well as DOSH. So thanks to Iwani. Okay, so last but not least, I would like to also thank all the participants. Even though we are running out a little bit of time, you all still stay with us. And thank you, and stay safe and stay healthy. So I pass back these sessions to Peg One.
Mr. Chen, thank you very much for your closing remark. Before all of you leave, just two other things. We would very much thank you for your participation at today's virtual workshop, and we hope that you can just take some time to give your feedback about this webinar. You can either scan the QR code, or just now I have posted the link for you to give feedback. If you have any other subject matters that of interest about the industrial gases industry, you can always put it under the other remarks column, and perhaps from there we can take it up and have further discussion with DOSH to have future activities such as this. And finally, if you have not recorded your attendance just now, please remember to do so that we have a record of who attended today's virtual workshop. With that, thank you very much to all of you, and have a good day ahead.
Thank you, Peg One. Thank you, everyone. Bye.
Thank you, everyone.